Welcome to the 9th session of the conference. The chairperson of the session are Dr. Ganesh Kedar, Professor and Head, Department of Mathematics, Rashtrasant Tukloji Maharaj, Nagpur University, Nagpur. Dr. Bharat Bhanvase, Department of Chemical Engineering, LIT, Nagpur. I request respected Kedar sir and respected Bharat sir to please come on dais and occupy their seats. Please, sir. Thank you, sir. Now I request Smita Acharya ma'am to welcome our chairperson by giving sapling as a token of love and appreciation. Thank you, ma'am. Now I request chairperson for further proceeding of the session.
Good morning. So today we have with us Dr. G.P. Singh, Professor and Head, Department of Mathematics, VNIT Nagpur. He will be delivering lecture on recent developments in cosmology. Dr. G.P. Singh did his BSc in 1984, MSc in 1986, PhD in 1982 from ITBHU. He is teaching mathematics from BTech, MTech since 1995 and MSc students since 2012 at VNIT Nagpur. He has excellent research record. He has published 81 research papers and he has completed 3 research projects. He has guided 6 PhD students and 2 students are working with him now presently. And he has guided 15 MSc project students and 2 students are working presently with him. He has excellent citation record also. You can say Google Scholar citations near about 1732, ResearchGate 1362 and Scopus 1069. And he is a reviewer for several national and international ACI journals. He is a PhD examiner for NITs or different universities and delivered several sessions, chaired several sessions at different conferences. He has visited abroad, you can say University of Zululand, South Africa, from April to June 1996 and October to November 1998, and then University of Natal, Durban, from June 25 to 30, 25th June to 30th June 1996. He held several fellowships such as JRF, SRF in 1987 to 92 and at IT, BHU, presently it is IIT BHU, Varanasi. PDF in 1993 to 95 at IIT Chennai. He actively involved in developing different courses and taken great initiatives in developing different courses, laboratories at VNIT. He has taken lead in starting MSc program in mathematics in 2012 and taken lead in preparing new courses for MSc and revising existing courses of BTech and MTech. He is actively involved in different continuing education programs name a few, you can say 2 conferences, 2 HTTP, 5 workshops he has organized, participated in several HTTPs, schools, refresher courses and conferences, and delivered several lectures at different levels. He is a member of different learned bodies, council member of Indian Mathematical Society, life member of Indian Mathematical Society, then Indian Society of Technical Education, Indian Association for General Relativity and Gravitation. He is associated with Inter-University Center for Astronomy and Astrophysics, Pune. He is member of Board of Studies at different institutes in and around Nagpur. He has handled several administrative responsibilities as a dean in 2013-16 as a dean student welfare, then dean planning and development 2018-2021. He has, I think, 3rd term for head of department and chairman of BOS Mathematics. Earlier he was head of department and chairman BOS Mathematics 2011 to 13, then 16 to 18, and presently 2021 to 23. He is chairman at several administrative activities he has done. He has handled at VRCE Nagpur, that is VNIT Nagpur. Such an excellent profile he has. So I will invite him, invite Kedar sir to welcome Dr. GP Singh sir. Sir, please. With the sapling. Yes. Thank you, sir. So I request Singh sir to continue his session. Thank you, sir. Please.
इसे okay. Okay. So okay, I'll try. 5 minutes पहले just you inform me. So I'll. Good morning to everyone. I am first of all I am thankful to the Nasi Nagpur chapter and office bearers of the Nasi Nagpur chapter, especially Professor Gadhiye sir, Madam, and Umre sir, Kotamkar Madam, and others for inviting me. Today we are going to discuss briefly about the recent developments in cosmology. So, as you know that cosmology deals with understanding of origin and evolution of the universe. First relativistic cosmological model was developed by Einstein himself in 1916. After that, several people got interest in developing various models of the universe. So, the universe, you know that it includes space, time, matter, everything. So, as a subject, you can consider that the subject is, if in that set, if you consider, it is the largest set because the set is considering everything of the universe. So, its age is approximately, you can see that 13.8 billion years. It's an estimated age, and as you know that it contains stars, galaxies, clusters. So a typical galaxy, you know that it's a gravitationally bound system and it's made of a huge number of stars. formation of first galaxy is started uh, after 1 billion years of the origin of universe. This is the some pictorial development in the evolution of the universe. So if you consider the time from origin of the universe, then 10 to the power minus 43 second we can consider as a Planck era, and after this up to 10 to the power minus 38 second we consider Gut era, grand unified theory, that area, and during that period elementary particle started. Then 10 to the power minus 10 seconds electroweak era, and 0.001 seconds particle era started, where elementary particles annihilated and matter annihilates antimatters. And if you see here that after 1 billion year first galaxy formed, and we are at present we are observing this 13.8 billion years. So as you know that the cosmology is concerned with the large scale structure, stars, galaxies which are at very large distance. So how we can study their property, their movement, their formation? So what are the force which is binding all these stars, galaxies, clusters, heavy bodies of the universe? So that only there are, you know, that 4 forces: weak force, strong force, electromagnetic force, and this gravitational force. So the strong force is in a nuclei, weak force again it's a short range, and electromagnetic is related to the lights, and then only gravity is the force which is working at large distance. So in order to study the cosmology we need a theory of gravity, and in this we are knowing only 2 theory of gravity. One is given by Newton, so it's a well known, everybody was knowing prior to Einstein. Einstein in 1905 first suggested special theory of relativity, where he considered the Newton's against the Newton's concept that space and time everything is absolute. He given concept of relative. Then gravity was missing in special theory of relativity, and special theory of relativity was applicable only in inertial reference system. So it's not possible to have ideally inertial reference system, because everywhere matter is there and acceleration is there. So how we can make an inertial reference system? So that's why he modified, and in 1916 Einstein wrote a very beautiful field equation. So this is just so this pictorial that explanations short. In short, I want to tell you about the Newton's gravity. What says that it's attractive. Newton's gravity is attractive, attraction between 2 masses, 2 particles. Okay, and everybody knows that Apple story, but I'll tell you that even heavier body might have fallen on the head of many other people also, and nobody got this concept. So Apple is not the reason to tell Newton that there's a gravity. So Newton was working in that field, and that Apple incident has given just clue. So we have to work. We should not wait that something happen and then we'll get idea suddenly. It never happens. So Einstein gravity says that there is a curvature in space. Matter is there, and because of the matter, curvature is in space. So in general relativity, Einstein has proposed this field equation. In this field equation, left hand side, if you see, it is purely geometrical quantity, and right hand side the physics, matter distribution. So properties of matter is right hand side, and here geometry you are having left hand side. So it's a beautiful bridge between mathematics and physics, geometry and matter distribution. So on the basis of this, you can say that you cannot separate matter and space. Space tells matter how to move, and matter tells space how to curve. Both are, we cannot separate it. So these are the famous three crucial tests of the general relativity. And bending of light, I will just tell you about this. Arthur Eddington in 1919, at the time of total solar eclipse in England, he was observing the light coming from sun side at total time of solar eclipse. You know that sunlight is not coming, so some light is coming from other star, and that is they saw, and they found that it's a bending. So but we know the property of light, that it never bends. Light always travel in straight line. So you can if space itself is curved because of heavy mass of the sun, then the light will have slight bending. And this you can consider with a small example, like suppose if you are having a canal and there is no other forces, water is flowing, and put a piece of paper or wood, that wood or paper will follow the stream of water. If canal itself is having slight bend, then it will follow the path of this stream, and it will go with this bending path. So this was the proof of relativity, and there are other two proof also. It has been tested, so I am not going to discuss those proof. So then at large scale, principle of cosmology says that universe is homogeneous. Homogeneous means everywhere you will find same property of the matter, so there is no center of the universe. And isotropic means in any direction you look, in all direction you will find that universe is same. So no specific direction, no specific place, there is no center of universe at large scale. So how we can study the model? So only spherical symmetry. If you see sphere, if you are in a sphere, then you look in any direction, you will find that the shape is same. So that's why spherical symmetric. At that time, Robertson Walker, they have given a metric, space-time metric for this spherical symmetry, and Einstein used this using in his field equation. Einstein wrote a field equation, and then he found that the scale factor 1 by s, you know that in here 1 by s, this s square is scale factor. This factor means you are having here, this is a sphere, and scaling in mathematics, scaling means multiplication. You change the scale, kilometer to meter, multiply by a constant number, meter to kilometer, again multiply by a constant number. It doesn't matter whether 1000 or 1 by 1000, depending on situation you have to multiply. So scaling means multiplication. So if you multiply this sphere by a quantity, say s, and if you increase s, sphere size is increasing. So so Einstein, when he wrote equation, then he found 1 by s square is equal to 0. If you put it, then you will get 3 by s square is equal to rho. Here also rho is also 0, so solution is meaningless. And because of this, he introduced a new term, cosmological constant lambda, and this lambda is he introduced because he could not get S value. So after introducing this lambda, he got 1 by lambda power half as a S. So then he could get a solution. Just after 1 year later, there was another person, De Sitter. He considered a vacuum model and he got expanding inverse. At that time, Einstein was solving his field equation for static inverse, because there was a belief, everybody was believing that inverse is static. That's why he wrote his field equation for static model. But even people were not accepting this expanding model of the De Sitter. Later on, Friedman in 1921, he found a solution with expanding model of inverse. So he considered S as a function of time. And then he wrote, if you see that Einstein used the metric, in this case 1 minus r square, only spherical symmetry, whereas this Friedman has used dr by 1 minus kr square. So k is equal to 0, flat model, open model and closed model, we can consider it. So for all the three cases he have obtained the solution, but still people were not having belief that whether inverse is expanding or not. These are the just information about the geometry. If you are having closed geometry, then you know that triangle. So some of all the angles of triangle more than 2 pi, in flat model, flat case exactly 2 pi and here less. If you consider a simple way, two ones, suppose if they travel in flat model, if they are starting parallelly, they will go parallel. If closed, then they will meet. If you are having negative curvature, then they will be having more distance between them. So in 1929, Hubble, when he saw the redshift, Doppler effect, redshift, then this is the picture of the Hubble. So then he showed everyone that you look, there is a redshift, means observer and source both are going away from each other. Then people realize that yes, inverse is expanding. And then if you consider the Friedman space-time metric, whatever he has given, in Einstein field equation, if you put it, then you will find that energy conservation equation is like this, and we can consider the equation of state rho is equal to omega p, and we can use here, we can solve this. After solving this set of equations, we will find rho is proportional to a to the power minus 3 1 plus omega, and a is going as t to the power 2 by 3 1 plus omega. This is the most general solution of this model. This model again suggests that Big Bang means when universe starts. From there, if you are having closed universe, then there will be definitely a big crunch, and universe will achieve its maximum, and then it will slow down, and it will be further. It's going to, sorry. So, and if you are having flat inverse, then it will forever, expand. Then when Big Bang means the inverse exploded from the point, that point is considered as a Big Bang. And Big Bang, just I'll tell you that the name was given by Fred Hoyle, and this theory was suggested by Stephen Hawking. So Fred Hoyle and Professor J.V. Narlikar, these people, they were working on steady state cosmology, and at the same time Professor D.W. Sharma and Stephen Hawking, they were working on an inverse model starting with the singularity. But those days Fred Hoyle name was much familiar in in the scientific world. So when BBC correspondent people, they ask that, sir, what about the other theory, the theory which start with singularity? So he just in sarcastic way he said that you are talking about Big Bang, and later on that the correspondent, he published this name Big Bang and people consider it. Then after few years later, there was a survey, and people, all the scientific people, they were asked that you please give a better name for the inverse model which started with singularity, and more than 80% said that Big Bang is only suitable name. So Big Bang means only that the point from where inverse exploded. So after that there was a huge, that explosion, and it was very fast, inflation. So that how this inflation happens, and from where energy came to inflate the universe. So once Stephen Hawking and other people were in one international conference, and they suggested that only gravity is there. So only gravity might be, help in this inflation. So at that time, in 92, I joined IIT Madras with Professor Johari. Professor Johari was in the same university as a postdoc when Stephen Hawking, Jayant Narlikar were PhD students. So he told me that look, that Hawking told this gravity inflates the universe. Can you prove it mathematically? And luckily we were able to prove it. And this our result was published in General Relativity and Gravitation in 1995. It has very good citations, more than 100 people, citations it got. I am not going to in much details. How much time is required, sir? So, 4 minutes, okay. So, just I am skipping this calculation part. We have proved this, that that here rho, the energy required for inflation plus gravitational energy is equal to 0. So you can take this one, rho gravitational energy this side, then you will get a negative of this one. Okay, so means balances. Only gravity gives you energy gets transferred to this one. Next, what is the future of the universe? So the future is depending on the observed matter and the critical value, density, critical density and observed density. And this we can consider with this ratio, that dimensionless quantity m observed and m critical. So this omega is greater than 1. Suppose if it is greater than 1, then inverse will collapse on itself and will have closed model. And if it is 1, then inverse will slowly stop expansion and it will be a flat model. And omega less than 1, then it will continue to expand forever, open model. Observation suggests that omega is close to 1. So it means inverse is flat. Now this is the just pictorial representation of that too little matter and energy, you are having open inverse. If you are having too much, then you will have closed inverse, and you have just about right, then you will have a flat model. So this is the matter and energy curve space. Now there later on again inverse age predicted as 13.8 billion years. We are able to present it? Before that, earlier we were thinking that inverse age is only 10 billion years. Later on, when we got better and better observational results from the supernova and Hubble parameter, then we have calculated that when we were knowing that inverse age is 10 years old or 10 billion years old, and later on it is observed that the global cluster estimated age is 12 billion years. Then again people thought that where is wrong, that cluster which is a part of the inverse is older than inverse, it's not correct. So then again they started this looking on the observational values, and the recent observational value of Hubble parameter 70.12 kilometers. If you insert in this formula, I am not going to read this, then you will find that it comes 13.8 billion years. That's why we say that present age of the universe is 13.8 billion years. And you can see that in this case, omega, if you put 0 for present inverse, omega is 0, then we can get this a is going as t to the power 2 by 3. So a is 2 by 3, so you can consider it 1 by h naught, and this t is equal to 1 by h naught. So 2/3 of this present age that model suggests. So that's why people started looking that what is wrong, and we have to modify further our field equation. So then and this basically came in 1998, this observation, supernovae observation, and after that everybody started considering that there is some energy, something is there that inflates the universe, and that since it is not known, it's a mysterious, so people have given name as a dark energy. Again, people consider cosmological constant, and they said that it gives a repulsive force. So repulsive pressure, negative pressure, if negative pressure is there, then there is an expansion. So again people considered this cosmological constant and started working with this cosmological constant. These are the dark energy and baryonic matters. You know that it dark energy will accelerate the expansion of the universe, and this is the just pictorial presentation of that. Initially gravity was able to slow expansion of the universe, but as universe expands, the repulsive force of the dark energy overcame gravity and causing the universe to expand ever faster rate. So you can see that Big Bang is started, then rate was slowing down in this region. So deceleration parameter, during this we consider that there was a deceleration, and after that again acceleration is there. So in this case, if you see the dark energy content of universe is, which we are not knowing, and it's still unknown, it's near about 73%, whereas the dark matter is 23%, and where we live, all these you can consider the normal matter only 4%, where we can consider, you can see that the galaxies and whatever we are knowing and our environment, you know that all these things, everything is in only 4%, and you can see that 96% is not yet known about the universe. So the dynamical nature of this cosmological constant played its important role to accommodate accelerating universe, and this cosmological constant has a wave type history, means it started by Einstein, then people consider it has gone up, then when people got the idea that universe is expanding, then they neglected it, so again came down, then again in deceleration model some people consider it as a source of particle creation, it gives energy, again people consider it came up, Then again they said no, it's not, again came down. And now after this accelerating inverse, again people have considered it, again it is going up. So, there's a future of this, that is just oscillating. There are several ways we can construct the accelerated expansion of the model by modifying the geometry or by modifying the field equations. So there was another person, Lida, who modified and the geometry, and in this case the term which is coming gives more or less similar role as cosmological constant, but beauty is that it comes from geometry, whereas cosmological constant directly he has introduced in an ad hoc manner in the field equations. So if you consider this, the possible model of the expanding inverse, if inverse you can consider the present, you can see this here, that a decelerating inverse, if you consider it, then its age is less. If you are having ever uniformly growing inverse, so then also you can say its age is more, but not in comparison to the more sufficient with accelerated expansion of the inverse. So if we are having accelerated inverse, accelerated expansion of the inverse, then you can see that the age we are having here present, and you see the starting point. So age is more. So here this accelerated expansion model gives you a correct age in comparison to the other models, which we consider now 13.8 billion years. So, okay. So cosmological models with accelerated expansion are currently at great astrophysical interest. Two main topic of research interest in relativistic cosmology are cosmological model of a very early inverse and accelerated cosmological expansion at the present epoch, as evidence, for instance, supernova observation. And theoretically, as I said, that many ways we can construct accelerated expansion of the inverse. Then conclusion, I'll just say that the new discoveries such as dark matter and accelerated expansion lead us to refine our model, and the scope of our understanding of inverse is limited, as observing instruments are limited in their ability to observe, and our knowledge of the law of physics on which we base our exploration is by no means complete. Science is ongoing process, forcing us to test our model through prediction and observation. The more test it passes, the greater is our confidence in it. So, because you know that day by day our instruments are improving. So earlier we had only optical telescope, then we are having radio telescope, now we are in a space satellite we are having. So many things, new things are coming up, and hence we are modifying our theory. Theory and observation experiments go hand by hand. So last, I'll just end with the quote by Albert Einstein, that most incomprehensible thing about the universe is that it is comprehensible. With this, thank you very much. कुछ पूछना है?
Hello. So if you have some questions, we'll take 2-3 quick questions.
Yes. Is dark matter equal to black hole? No. Dark matter is not equal to black hole. Black hole is only gravitationally strong region. So dark matter we have not observed. That's why we are saying that it's not. And for black hole, only boundary we are able to get. Not inside black hole, but is because nothing is coming out from the black hole. So we don't know about the black hole. Yes.
Do you mean that it is antimatter?
Huh?
Dark matter is dark energy is antimatter.
Dark energy is not that. See, it's not antimatter, because if you know the things, then there's no, antimatter is a property. Dark energy is not yet known. So we cannot say that dark energy is equal to antimatter. No. Antimatter should not.
Antimatter is also not known, but then there are certain evidences that it exists.
No. See, two things are not known, so you cannot say these two things are same. If I don't know you, if I know something, I cannot say both are same person. No, that imagination is there because that when we are having wires, in wires, so how these wires are filled. So that's why we thought that, people thought that there's some matter is there. Some matter is there, that's why they said that it's a dark matter. We don't know property of that matter much. So that's why you can see that. Just I'll. See, the dark matter, it's a non-luminous object. It has no interaction with photons and is incapable of emitting any electromagnetic radiation. Dark matter should consist of chargeless neutral particles and it does not undergo any electromagnetic interactions. So that's why we say that only how these wires are there. So that's why they said that there may be, they have given the dark matter. So it's a mysterious. That's why we say that mysterious. We don't know. We don't know much about.
If we achieve the velocity greater than electromagnetic radiation, then maybe that interaction is possible because electromagnetic.
If we achieve, but we have not yet achieved. When
So such mathematical modeling is there, how we can achieve the velocity greater than the. Is it?
no, we have not. Forever, because no, it will not stop because it's a flat model. Never it will start. Closed model, we will have a maximum limit and then there will be a crunch. But the observation suggests, see that what's the difference? Earlier, belief was the universe is static. Later on, when Hubble saw this, that there is a redshift, belief changed. And then people started that universe is expanding. But expanding rate is slowing down. Why people started considering that slowing down? Later on when they considered that when there was a big explosion and inflation was there. So if at the same rate, if inflation is there, universe is expanding, then it might have very much expanded. So they said that no, it never happens because the rapid expansion, the inflation after that rate is definitely slowing down. So if rate is slowing down, universe is expanding, rate is slowing down means deceleration is there. So up to 1998 everybody was thinking universe is decelerating. Now people are trying to fit their model in decelerating model of the universe. So we have also written so many models during those days. 92 to 98 I was also doing work. So all models were decelerating model. 1998 supernova observations came and you know that even that supernova explosion was observation came in 98. But this explosion might have occurred long back because it's so light years away from us. So why we are able to get it? Our optical telescope got modified. After optical this telescope, we had radio telescope. Now we are having in satellite. Even optical telescope also much advanced in comparison to 1929. So day by day we are getting new information. When we are getting new information, concept is also changing. And that's why the experiment and theory both दोनों कंधे से कंधा मिला के ही चलना है because that depending on the prediction whatever experiment suggests, theoretician also they try to make fine tune in their theory to match it, and then by that time instrument also get advanced, they get a better result. Here also people are trying to make it. So that's why, since we are not knowing confirm about this dark energy and dark matter, so that's why we are considering it's a, still people are talking about the dark energy, dark matter. But we cannot, unless we know something about this, we cannot say that it is antimatter. We cannot say it's because if you are going to say, then you have to prove it something. So that's why. Huh. Hmm. Huh.
Every time we have this dark energy is 73%,
Huh.
matter 23%.
Huh.
So when we are not knowing the dark energy,
Huh.
how can we calculate the 100% and the 23%?
This actually, when we are getting observation, see, observations, from observation what we get, we are not able to get the density, we are not able to weight these things, mass we are not able to get, we are not able to get volume, we are not able to get. What we are getting with the observation? We are getting luminosity. Luminosity of bright objects. Okay. So from that bright objects, we are getting luminosity. With help of luminosity, we calculate the distance, and with this we can consider the Hubble's law, that V is equal to hd. So distance proportional to velocity. We consider the age, we can consider. So theory predicts, your theory predicts that it should be this much. Observation suggests that on the basis of observation, whatever we are calculating, we are getting this much only. Okay, so it means that whatever theory is saying and the observation is saying, there is a gap. So if there is a gap, then this gap is what? How we can compare this gap? So this gap is, we consider is a energy part, the difference between the observed energy, critical energy of universe we calculate, and the theoretical prediction. So the difference is 73%. So if we consider 73%, it's an approximate. You read many books, you'll find somebody write 74, somebody 72. It's an approximate. Nobody can tell you exact value. So in some book you'll find that 5% of, I told you that in 4% we are all, some book you'll find 5%. So it's a judgment matter, 1% is there. But the calculation is only with help of this luminosity. So theory and observation, both calculation, what the difference is there, that we can say it's an unknown quantity. Unknown, we don't know about that. That's why people have said it's a dark energy. And so many models people have used, various fields. You'll find number of theory predicting that this model may be more suitable for this. So all models, whatever they predict, and observation, whatever we are getting, we are trying to match it. If match, then we can say that it will be a better model. Now again I will tell you that why we are matching, how this model will help. Suppose if I get, this is a better model, what it will help, what's it going to help you? So very simple way, I'll just tell you. We are having, suppose we are having some data, and we are teaching curve fitting, So if we are, suppose if we are fitting a straight line, we are having say 100 data, and we have fitted a straight line. Fitting of a straight line means what? A straight line which is having minimum distance from these all the 100 points. It's having minimum distance. Suppose if this is the best fit line, then you know the equation of a straight line. Now you just put y is equal to ax plus b. If you a and b you have find that, say for example 2 and 3. So y is equal to 2x plus 3. Now you take any x and find the value of y. So if your data is fit, you can just put x is equal to 1000, you can say billions of years, and then you can say why will be like this after this. So that's why we are trying to make the theoretical model. So in theoretical model, one information you just put, another information you'll get, and you can say that after this year this will happen. So that's why we are trying to make it sense.
अच्छा ठीक. Thank you, sir. This was very interesting lecture, and as a chemical engineer, I can understand something out of this. So that was very interesting, sir. I request Kedar sir to felicitate Dr. Singh sir with shawl and memento. Thank you, sir. Bas. Next one. Bas. Okay. I request Kedar sir to take for this next proceeding. Please.
So, cosmology is really very big field to explain, and rather to explain the layman, it is very difficult. But in very short time, Dr. Singh have done this task, and I think most of the audience is very pleased with his lecture. Thank you. Now. We have another speaker over here, Dr. Bhaskar, Director NBSS Nagpur. His topic is Geospatial Technologies in Advancement of Agriculture Research. And I am going to give the brief introduction of him. As he born in 1962, graduated in agriculture in 1979 to 1983 from SV Agriculture College, Tirupati, and he post-graduated in 1985 from the College of Agriculture, Bapatla. Then he had done his research in soil science and agriculture chemistry, Andhra University. After that, he joined as a scientist in 1991, ICAR, NBSS and LUP Nagpur. He worked as a project associate in various national and international projects like soil resource mapping of India, rubber growing areas of Kerala and Tamil Nadu. He published around 160 research articles in various national and international journals. President Dr. APJ Kalam also appreciated for the research article published in book entitled Flood in Assam, from the viewpoint of conservation of river bank erosion in Brahmaputra Valley. Presently, he is working on LRI project of various blocks in different parts of the country, and as his research is very huge because he published near about 160 research articles And because he is related to the agriculture, and as we know, India, we are having a very large part which is depending on the agriculture. So his work is surely the noble work. So I welcome Dr. BP Bhaskar, and I request him to start his speech.
So, I am from a different field, from the field of agriculture, and our research is mostly of field orientation. We have traveled from Arunachal Pradesh to Kanyakumari, entire part of India we have surveyed, and I also involved in many of the projects of land resource inventory programs. Now it is a very interesting topic. Why? Because yesterday in Hyderabad, the Prime Minister of our country, Narendra Modi, inaugurated the United Nations Conference on Geospatial Technologies. And he mostly emphasized on two T's. One is technology and another is talent. So these two things that will bring the transformation in the field of agriculture. Now the farmer can see his field at his own desk. So that is the level of technology at which we are working, and we are generating the soil resource information. This is the topic, what a very hot topic. And how we look into the sustainability, that is very, very important. As an agricultural scientist, we will look into three basic elements. These are very, very important for us. One is environment, the second is society, and the third one is economics. The sustainability is a topic to an economic aspect. So this was how it was evolved. That is very, very important. This is the technologies, how we are using. Now we are able to trace out an object which is having at 1 meter interval. From this to this, we can identify what is the crop. And very interesting question is, when you have a crop technologies, where, why, and when? These three questions we have to answer to the farmer. Where means to which crop, under which landscape element, why? That means if anybody asks, what is the type of fertilizer I have to apply to a particular crop? What is the extent of pest attack that is causing damage? And we are seeing which are the regions that are affected with the floods because of excess rain yesterday night, what you have experienced. So all these things we have to say why we have to address what kind of problem and when. When you are going to address these issues. For this you need these geospatial technologies that are available, and I will try to say for us, for an agricultural scientist, we always ask about the ecological footprint analysis. It is very, very important. These people, whenever we refer this particular concept of ecological footprint, we have to recognize three important scientists. One is Malthusian's population theory. And then this Rachel Carson, she was the first biologist who wrote a book on Silent Spring. There, he expressed his scientific article. That book, it became so popular that was referred in 1962 as a major textbook for knowing the pesticidal impact on soil pollution. She was the first lady expressed his concerns over environmental pollution with DDT, excessively used in United States of America. So that book brought, see, if you go on for indiscriminate use of fertilizers or pesticides, how it has an adverse effect on environment. And the third person is, in 1970s, this was Dennis Meadows. In the Club of Rome in the United Nations, he was the first person expressed what is the limit of growth. To what extent you can grow. So, in that context, he first draw a line between the number of people versus time. So, in the 1980 itself, if you take the ecological footprint of 1 hectare to meet the needs of human population, so many countries will go below. Only the America, Canada, there the people they are having more than 2.2 hectares per person. So this is of a great concern today. If you come to the India, you can estimate how many population, how much population 1 hectare of land that can give you throughout the year the basic needs you can fulfill. So this is the concept given by Dennis Meadows in 1972. So this 1972 concept, it was very well taken over by this Bundet report in 1987 from Norway. So now they started thinking about sustainability. See, if you go on, continue the industrial development and also indiscriminate use of fertilizers and pesticides and over-exploitation of the mining areas and also your coastal and marine resources to the teeming population. So are we going to sustain in future? So this is the basic question that was very well taken in 1992, the Rio de Janeiro Research Summit. This sustainability, they have made an agenda 21 under a special paragraph 3. So now it is the time for looking into this sustainability development. And at this, the people have started on defining what is sustainability and then what are the standards you have to put it to say that your system is not sustainable. That means sustainable indicators. Now people are working on what are the sustainable indicators. You can say that your environment is safe. That is how the concept was evolved. Looking into, see, that is the diagram he has given. And on this particular concept, Malthusians, after Malthusian population theory, the Hardin in 1968, he wrote a letter, a popular article. So that was the best ever scientific article published in United States, New York Times. So that was, that will available in your net. If you have a time, you please refer that Hardin 1968. So he was again giving a impetus for this particular population theory and environmental concerns. So if you see all these things, now my subject, the soil, which is a life supporting system, the people started looking into the 6 basic elements that are involved in the soil. The soil is not because we are all working on this, looking into that. Soil is the fabric of human life. That is woven, the earthen looms are woven in it, in which everywhere it smells of clay. So if you see the basic research of agriculture or any field, the basic functional material, whatever we are the hereditary material, what we are saying, the DNA. DNA can be extracted with the clay. The life is hidden in the clay. That is a functional material that can be used in various sciences. So for that, 1954, the people have conducted an experiment with the combination of ammonia, ether and hydrogen plus water. They have prepared first amino acid. Then the same experiment, once you have an amino acid with this basic elemental composition, if you put clay in that, so the first RNA was extracted from this experiment. This RNA is similar to DNA, what you have in the basic life hereditary material. So that is the reason why the people then realized soil is a life supporting system. That's why we will say that it is a natural body which is having a distinct horizons, wherein we can see the human life, the prosperity. That's why we will say, whenever the land subject we are dealing, the basic question what we will ask is, 3 P's are important. One is people, and another is policies, and third one is prosperity. See, whatever you are doing, your activities in any field of the science, because generally agriculture is the mother for all sciences. If the people are not hungry, then you can think of any field. That's why in agriculture, what we will do is, the basic material for us is the soil. Then the recognition of the soil as a natural resource. That is another big scientific challenge. People have struggled 200 years to define this particular object. Generally, we considered Dokachev as the father of nation, father of pedology. So he started defining the soil is having the distinct layers. That's we say it is a horizons, which is having a defined physical, chemical and biological properties, wherein over millions of years it is feeding the human population. Now, what you are feeding to the soil? Nothing. Over millions of years it is feeding millions of the people throughout the globe. That's why now the people have started, see the development of, it is a fully the knowledge-based systems people started. So first thing is you need an education. Through education you have to practice, and then you have to develop the terminologies. These terminologies that will change subject to shift with the time, and then these is the two things that brought a revolution in this particular field of science, and that is factors of soil formation by Jenny and the soil landscape relationship by Milne in 1936. These two people, they brought a great revolution in this particular field. Now we are able to generate and prepare the land soil maps that we are practically using it for crop management and also in environmental analysis. These data sets are very, very useful. So coming to the why we say it is a knowledge system is, before we are going to the field, if you take a topo sheet, you need to have specify the area where in which you are going to survey. The scientific investigation starts from that. You have to specify where you have to, and you have to conceptualize what you are going to do, where and why. That conceptualization, the formulation, for us is the toughest part is implementation. The implementation part, because you are directly dealing with the livelihoods of the farmers, and then the production system analysis, one should have a very sound knowledge. Because once your production system you want to transform what effects it has on the livelihoods of millions of people. It is not of easy joke to say that I will do like this, I will do like that. No. This production system transformation, you need a lot of data sets at this particular point of time of implementation. And testing. Testing, you have to involve the people in your activities. That is participatory approach. We have to follow. Unless the farmer will convince, you cannot push up your technologies or ideas and innovations. So the proper care should be taken in formulation of the policies, especially for fertilizer, and also to the crops and seeds, and the alteration of or modification of any crop changes in a particular area. So coming to the, see why all these things are is there. Yeah. Now, next one is the scale. The scale of information at which you want to generate the information. So at continental level, at regional level, or at local level, all this is a scientific approach through which you are going to generate this scale of soil information. So, one scale of information you cannot use it for another scale. It is highly objective oriented program wherein you can work only with single idea with multiple scales. And why? The changing of the models of the soils, especially now people are talking about more of soil organic carbon. It is very, very important where our Indian soils are having lot of changes in organic carbon, where the anthropogenic activities, we are changing the land, we are changing the crops, we are adding so much of material, waste materials, everything. Because the sewage water, people are using it in the irrigation systems in urban areas. So the sewage water is having a lot of lead, chromium, highly toxic, that can be easily taken up by the crop. So, according to the use of the soil through your management systems, lot of changes you can see in the soil organic carbon status, wherein your concept of soil is changing. Now people are telling anthropogenic soils. The original soil we already lost. Everything was changed with man. Man is the most culprit in bringing a lot of transformations in the environment. We are not allowing the environment to function. So this consciousness one should have it before going to apply our technologies. And these are the processes, how much time it will take. In the soil, if you take the mineral dissolution, it will take millennia years. So, what this slide speaks is, soil is a library of past, present and future. You can see the past, you can see the present, you can also see your future. Your future is only by seeing a simple soil profile body, you can say how much you can produce a crop and how many people you can feed. Through these layers, you can clearly come out with how it is possible now. Yeah. This is the actual knowledge, you must have it. Soil is a biological entity. It is only not an inert material of rocks that weathered, and it is not a dust or a dustbin. So it is having a structure. Why it is a life, why it is a living entity is there? Because it will breathe in and breathe out. So in the breathe out process, the CO2 all carbon emissions, everything people are talking, that respiration rates, if it is changes, as the climate, it will change. Whenever you are addressing the climate change, the soils are the first material people are testing now. So if any change in the environment, that will be reflected in the soil bodies. That's why it is a storehouse of so much of knowledge, bearing in mind that we should be very careful in handling these resources. This is what the basic research what it speaks. Now the technology is, with us is remote sensing technology, where we are applying the basic physical principles of electromagnetic spectrum in identifying the objectives on the Earth's surface. So that is another field of geomorphology plus physics. You are integrating and identifying how our landscapes are. So in that, the main thing it will cover the forest cover, the agricultural land use, the plantation crops, and also you can see the types of human activities and its effects, especially the flood hazards, the glacier melting, all those things, this remote sensing technology, people are widely using. And we are also using for knowing the surface, Earth surface features and the changes that are happening over a period of time, how it is. Only I will give you. This is how so many applications in agricultural research. The cropping pattern, the crop yield forecasting. That is very, very important for stock exchange people. And then the irrigation patterns. We have to see so much of knowledge about topography, the elevational patterns over which the soil is sitting, under which the farmer is cultivating. If you go and encourage the row crops, it will increase the erosional rates. If the topsoil we lose it, whatever applications you are making, all that money, you are wasting it. It is of no use. So the erosional patterns, that is what we say, the land degradation. The biological productivity, it will go on declining. If you refer so many ecological papers or environmental papers, the land degradation is at the first step. You have to address the land degradation. At what cost you are producing what yield. So, this is the level at which we are going. These are the geospatial data sets we are generating, and also the modeling. Nowadays people are working on modeling also by taking the temporal data sets. And also we are predicting the soil bodies, which type of soil bodies, where you will get, and what should be its surface properties, and what type of conservation measures, where they are implementing. The monitoring systems are very strong now. So I have spent 10 lakh rupees for construction of a check dam, where all your activities are coded and tagged with the technology, with the GIS and GPS systems. You can monitor. So coming to the contribution of geospatial and other things, all that data is not needed. Now you see the monitoring of NDVI. This is very, very important property. People are using it. Especially you go for a split recommendation of nutrients at critical stages of the crop. So this NDVI values, you are going to measure it in the field itself. That is field imaging techniques. The green seeker, the instruments are available now. You can check the NDVI and you can recommend the nitrogen to the crop. This is a site-specific nutrient management techniques that are coming up. And crop area estimations, you can make it. And then the crop damage assessment because of drought, that also you can. These are the instruments that are available. This level of technology we are widely using And I will show you one case study. These are big bird images. This is what I told, 1 meter recommendations you can see, and how the lines, the crop lines are there. That also you can monitor. You can map it to answer where, why, and when. So instead of wasting so much of chemical by spraying or by broadcasting, now you can see where I have to spray, how much I have to spray. So you can optimize your resources and maximize your output. So that is the important aspect of agriculture. And and I will show you one case study here, what we did it in these technologies. This is how the nutrient recommendations. The nutrient recommendations with NDVI values. Now the models people have developed, and also they will monitor this reflectance properties. Now actually the tractor mounted spectroradiometers people are implanting, and they are judging the surface soil properties at the time of tillage itself. You can see how much variations you will get for each row within the row, between the rows. You can see what is the elevational differences. That can also, you can do it. The technology is so advanced now. Next. Next कहाँ है ये? कंक्लूजन में आ रहा है.
हाँ सर, लास्ट स्लाइड है.
लास्ट स्लाइड है, आप लोग डाउनलोड. या वी हैव फाइल ठीक से नहीं निकाला. या ये है,
वही ओपन है सर.
या और एक फाइल है आप लोग. या so we have conducted a case study in Kadapa district of Pulivendala Tehsil, where the land use dynamics is so dramatically changed. It is a drought affected area, which is very well known in the country itself. The drought prone areas of India, the Anantapur and Kadapa are two important districts where the crop technologies are very difficult to evaluate. So through this land resource data sets, we have studied that area, and then we have come out with some of the recommendations, and then in that what we have done is we have taken 110 years of climatic data, monthly climatic data, and then we have analyzed what are the wet and dry cycles of rainfall that is occurring in that particular area, and then we have tagged with the yield performance of groundnut and red gram. So we have seen that there is a distinct relationship between the rainfall patterns and the yield of the particular crops. One of the interesting point is from 2008 to 2014, there was a severe drought for 5 years in that particular district, and the groundnut area was drastically reduced to 10,000 hectares, and earlier it was 2.2 lakh hectares of groundnut area. Now it has come down to 10,000 hectares. You can imagine how much burden we are putting on groundnut oil. That entire production system, 2 lakh hectares, you cannot get it in any part of the country. So that is now also in my own district, the groundnut area was totally reduced. Farmers are refusing. Now all farmers are going for this banana cultivation in these drought hit areas. Now the government is giving so much of incentives. That is why the policies are these are the directive elements that will dictate the farmers to change their cropping pattern. So this cropping pattern, yeah, this one you see, this particular, this particular district we have made and we have regional studies we have submitted to the government of Andhra Pradesh also. So in that all this ecologically very sensitive area, because Kadapa is known for mining. Mining is a primary activity, agriculture is a secondary activity. And mining, it has gone indiscriminately, they have explored this Kadapa slab. If you travel from Tadipatri to Kadapa, see everywhere you can see the rat holes, the way they have exploited all this Kadapa slab. And these lands are permanently not used for agriculture. So, that too, this area, actually you can see the ecological footprint here. The irrigated land is less than 0.2 hectares. And cultivated land is almost 0.6. So, in some villages, you don't have any forest and irrigation. So, this is the state of our ecological situations. If you see the per capita availability of land, most of the almost 40% of villages are already under threat. There is no alternate source for them to create. And all people, they will migrate to Bangalore, the urban, because Bangalore is prospering now. So all these people, landless laborers, they will migrate to urban areas. So they are creating really the problems to the Bangalore. So this is how we can see only the August and then November are the heavy humid periods, and the rest of the period you can see very dry periods. So all this kind of analysis we have done, we have taken the landscapes, we have taken the productivity analysis, and then we have established some of the crop calendar. Agriculture, the basic, we are very much thankful to our forefathers because the greatest contribution is a crop calendar. They have fixed. The fixing of a crop calendar itself is a basic scientific achievement of a farmer. Crop calendar is very, very important. After season over, so you cannot sow the crop because everything waits, but not agriculture. That is what Jawaharlal Nehru told. If the June comes, the farmer must be ready with the seed. Otherwise, once the season was lost, everything lost. So, these are the, see the banana is coming up even in uplands. People are pumping how much energy they are putting in pumping water, and they are using for drip irrigation. The technology wherever they can apply, they are applying already. And they are exploring, and over exploitation of groundwater also. Because banana demands more water and its duration you have increased it to 1 year. The groundnut is of only 90 days. Now you have increased it to 250 days. So how much pressure you are putting on groundwater? So these are the things in these particular areas. And then the land resource maps and suitability maps, all this was generated, this information. And when we analyzed the economic analysis, that is what we said. Only 20% of your groundnut area is economically profitable, and the rest of the mapping units, even if you put up your labor, you don't get it. That is the state of economic benefit of a dryland farmer in a drought affected area. So this kind of studies government is encouraging now. Now people are sitting for how to go for crop diversification. So especially when you want to make a policy document for dry land agriculture, these land resource data sets are of immense value. And now people are going for the fast way of generating these land resource data sets. They are using a DEM data, now digital elevation models people are using, and then they are reducing the time scale of a field activity, and then they are devoting more time how we have to go for crop planning very fast. So these are the data sets that are available for every team. Okay, 2 minutes. Okay. Yeah. Now, ultimately, people, after doing all these exercises, for whom you are doing this? This is only for participatory approach. Unless people will involve, even if these data sets, to implement and test your ecological principles, so people must be the center of activity, and ultimately these data sets are going, now the blockchain technologies, people are talking, the government policies and the production systems and the market creations. Now the government is thinking of how these production systems are really functioning, whether it is sustainable or not sustainable. If it is not sustainable, what best we can do? So that we can put up the policies for pulse development, for oilseed development, for cotton development, for mango development. So now the commodity-oriented research in a particular region, it has to be identified, then you make a policies so that in ideal marketing facilities you have to create to a commodity, you have to tag up your management practices. From which piece of land, what produce, that has to be tagged and then marketed. So that is the level this technology is going to link up in future, and it is having a very bright future. Now blockchain technology, all these land resource data sets that are flowing in various sectors and in various departments. So in conclusion, ultimately the agro-technologies, the farmer is center-oriented programs only, it will be succeeded. And what we have to do is we have to educate them, the kind of technology, what you are using, and what kind of information you are generating, and how you have to make use of it. See, because now the drone technologies are also now, government is very much interested to make a drone technology in agriculture. So we are also purchasing 2 drones from our institute, and we are also demonstrating to the farmers, saying that this technology can be, how much it is economically viable. Because if you have one commodity in your village, all operations from sowing to the pesticidal applications, fertilizer applications, with the drone you can apply. So you have to bring people together. Unless you demonstrate the technology to the farmers, the farmers won't come forward. So the farmer is center for adoption of our technologies, and this is the information what we are generating to the society, and then this effort will go on continue. So with this few words I will conclude my lecture.
So, any question from audience? No question. Okay.
Sir, with the pattern of this soil degradation, what you have explained, if you go on with this rate, how long our soil will sustain?
Already our soil has reached a level that, see how many football players you have in here. Football player, human health is a very good indicator to say what is the soil.
माइक नहीं है कॉलर माइक
We
है
have a big deficit. We have losing health.
सर तो कैपेसिटेशन है
Whatever you are eating,
ध्यान
the nutrition, what we say, the nutrition that comes from the soil. So what strength you have, same strength, a fellow who is taking the same nutrition, same food he is taking in Assam. In Assam people, they have a lot of bone problems because that water itself is low in calcium. But you people are so fortunate, your soils are rich in calcium. So that's why your body structure is very strong and your bones is very strong. And if you say the soil structure is very good for black soils, wherever the structure is good, the calcium is very high. That's why you have a very good bone structure is very good. If you see, if you go to Brahmaputra, after 60 years, the ladies will bend like this. They have a problem, bone problems, it will crop up. So that is one, visually you can notice that what is the link between the soil health and then to the human health. And another thing, if you see the sewage and the water wherever they are irrigating, now the complaints are coming up that the paddy grain, you are seeing the lead contamination. So it is a very, very important aspect because now I have not shown the geochemical properties. If you analyze it, what are the heavy metals that you can see in the soil bodies that will be reflected in your crops. So now the subject of soil is soil nutrition is always linked with your health issues, human health issues.
By generation we are degrading with it.
Yeah. If you see arsenic levels, now people are talking in Calcutta also you have arsenic because if you go on digging the drill wells, so arsenic will come into the, as you go deep, arsenic will come. So the arsenic tip burning symptoms you will get it. Once that tip burning symptoms will come, it is very difficult to cure it. It is very difficult from the system to wash it away. And the same thing what we will say is, you take water purifier. Earlier days, have you ever seen your grandfather drinking with a RO? Now, why in every house here now you have a water purifier? Why? So much we have contaminated. The way you live your life, that will teach you how you are polluting your environment. That's why that Meadows' 1972 speech, he finally told 3 things the society must realize. One is, try to connect child with the nature. That is the first step you have to do it. And you are not a consumer, you are a citizen. Why he told? For every person in a year, in this present generation, they are consuming 10 tons of metals, what you are telling, materials. 10 tons. How much you are using? It is only 6%. 94% is waste. Where you are dumping all those things? Soil only. Soil will act as a dustbin only. Biodegradable, if you add it, okay, it will degrade. Otherwise, it will remain as it is. Where it will go? The rain comes, the sunshine comes. If rain will carry away all your metals to water. Again, it will either it has to go down or it has to go up. The go up is only evaporation. So it is a very pure again. The moment it interacts with the land, again it will become impure. So that's why he told you are not a consumer, You are a citizen. So buy less. And whatever you are buying, that must have a longevity. So these environmental principles are very difficult to adopt at this age. But that's why he told you connect people, children to the nature. Then only it is possible. And also he cautioned they have created that creative programs in Japan. They have educated the children, Satyoma program. So that was very successfully run because how de-urbanization is one of the basic concepts. He also emphasized on that. And then the regional communities, they must participate in natural programs. So the more you live with nature, the more you will learn. As you are going away from nature, naturally, your degradation, how you can see degradation? Once you travel from Yavatmal to Dharwa, all hills, there is no vegetation. So what will happen if there is no vegetation? The first point is interception. The moment the rain falls, the raindrop impact, even it can break your big clouds into the minute particles. That much force from the sky it will come and fall. If trees are there, it will intercept at that particular point and its velocity will be reduced and erosion will be reduced. But the tree is, where is tree? Man is very much against to tree because even in my own district we don't see any vegetation. So these are the things. So environmentally we have to educate our community. So the way how we are living, so that will decide how we are. That's why sustainability concept came up. What is sustainability? The stability. How much you yield? If I say 6 tons of paddy, 6 tons of paddy.
माइक कवर कर लो सर ठीक है
No, if you say it is soilless farming, we can say the hydroponics. Now it is coming up in Bangalore also. And another they are telling, yeah, vertical farming, terrace farming, all those things that are coming up. But it is only to a limited extent. If you say as a whole of, I will say that paddy ecosystem. Paddy ecosystem means entire Assam is a paddy ecosystem. If you see in Krishna Godavari, it is a paddy ecosystem. If you see as a whole the entire system, the soil is a basic material, land is a basic capital. Actually we say in economic terms, land is a capital. You can do anything on that, farming, business, anything. But the soilless, it is only to a limited extent people are trying. But hydroponics...
Okay, sir. Yes. You people can discuss later on with him because we are running out of time right now. So without wasting more time, I request Dr. Bhaskar to come up on the stage to accept our felicitation. And also we forgot at the beginning of the lecture to welcome him with the sapling. So we are compensating that both of the things. So I request you, Dr. Bhaskar, to come up on the stage. And also I request Dr. Bhanuse to felicitate him with shawl, memento and sapling. Thank you, sir. तिसरं लेक्चर आहे.
लॅपटॉप पडल्यामुळे मॅटर नाही चालवत आहे पण पीपीटी आहे.
तुम्ही देता?
टायटल लेक्चर
काय करतो ते जाऊन
थर्ड सेशन
नाही नाही हे तुमच्याजवळ आहे ते तुमचं तुमच्याजवळ. ओके.
यूज ऑफ मॅटलॅब फॉर ॲरे अँड ग्राफिक्स.
फॉर
ॲरे अँड ग्राफिक्स.
तू होता है मुझे प्रॉब्लम है immediately होते हैं सर.
So, we have here the third speaker for this session, Dr. Shubha Daudpure, working as a professor in LIT. Her topic is use of MATLAB for array and graphics. Dr. Shubha Daudpure, she is professor and head of the Department of Mathematics at LIT Nagpur. Her specialization was relativity and cosmology for her PG degree as well as her PhD degree. She has 25 years of experience, teaching experience. She received Best Teacher Awards of Raisoni Trust and also received back-to-back 3 Best Paper Awards in international conferences. She has guided one student successfully for the PhD degree as well as 2 students are working under him for the doctoral degree. She has completed one major research project of UGC New Delhi and total amount mobilized was 5,51,000 for that major research project. She has published 26 research papers in SCI journals and in the international and national conferences. She has delivered many talks at various stages. She is also reviewer for the many journals and also chaired the technical sessions for the national and international conferences. She wrote one book also on engineering mathematics and organized training and learning programs as well as the faculty development programs on MATLAB. So presently, she is working as a chairman of Board of Studies for General Engineering Board in RTM Nagpur University. She has membership also for the very much academic societies, and she also visited Singapore and Ayuka Pune for her research. So I welcome Dr. Shubha Daudpure in this session and request Dr. Banuse to welcome her with sampling. Thank you. So I request Dr. Shubha Daudpure to start her speech and to follow the time schedule, 30 minutes for the lecture. So I think if she will finish in 25 minutes so that we can get the 5 minutes for the more discussions. Thank you.
Very good afternoon to one and all. Actually, due to some technical problem, I am not able to show you hand-on session. My laptop fell down and hard disk disturbed, so I'm not able to use on which MATLAB is installed. Actually, yesterday to take hand-on sessions, I have plot very nice graphs for you. But because of technology failure, I am not able to show you hand-ons, but I will show you how we can prepare the graph and how we can write array by using MATLAB. So why MATLAB? और ये नहीं mic नहीं है? Excuse me. Excuse me, I need mic. So it has a simple syntax, easy to get started with, easy to do graphics. Okay, and it is interactive. MATLAB is a software package for high performance numerical computation and visualization. MATLAB is based on matrix. So here the name MATLAB stands for Matrix Laboratory. So mathematical students will find it more interesting because the complete software based on the matrix. Many applications are there. Some MATLAB built-in functions provide excellent tool for linear algebra computation, data analysis, signal processing, optimization, numerical solution of ODE or PDE, and some own inbuilt functions. History of MATLAB development. MATLAB is now a full-featured technical competition environment with millions of users. But the three men behind this development of this software are J.H. Wilkinson, George Forstey, John Todd. In late 1970, the first version of MATLAB has been developed. These are some commonly used operators: plus, minus, multiplication, star. Then these are some left division operator, right division operator. Left division operator is known to you for 2 by 5. Left division operator is used, and vice versa the right division operator is used. Then these are some basic operators. And parentheses are important. That open parenthesis we can use only for function, and that square bracket we can use only for array. Vice versa, MATLAB will show error. When we launch MATLAB, I will miss that launching and everything throughout the lecture. When we launch MATLAB, these three panels will appear: current folder that access your files, command window, enter commands at the command line indicated by the prompt, and the third panel will be workspace. Here we can explore the data that we have created during our sessions. So there are the drawback of command window is we cannot edit command window. If we commit any mistake while writing the syntax, we cannot edit in the command window, but we can edit in the editor window. The other option is editor window. Here we can write, we can edit, we can create, and we can save the programs. Then data type. The fundamental data type of MATLAB is array. As I told you, basis for MATLAB is a matrix. So array, 1D array and 2D array. Dimension is automatic in MATLAB, and it is case sensitive. If you define a variable small a, then you have to use throughout the syntax small a. If you write capital A, then it will show error. Then these are some basic inbuilt functions which we can use. WHO lists the variables currently available in the WIS. Then WHO lists variable with a size, how many bytes that has been used. Clear is the word which we can clear the workspace. If we write the commands, obtain the result, then that will be stored in the workspace. So if we want to clear is the inbuilt function for that. Then CLC clear the command window. Whatever syntax we are writing in a command window. For example, we are adding two matrices. Then the result will be there. If we subtract two matrices, the result will be there. Then command window, if like a slate, पूरा होने के बाद हम लोग उसको delete करते हैं. So like that, CLC is the command in MATLAB which clears the screen. Those who have studied C programming, they are aware about how to write the variable name. There are some rules. The same rules we have to follow when we create a variable name in MATLAB. So we have to start variable name with a letter. We cannot use digit for writing the variable name. We can write later on, but start should be with a letter only. We cannot use special symbols other than underscore. So we can create the variables, we can assign the values to the variable, and then we can perform the operations on the variables. Arithmetic operations. Mathematicians know that for evaluating any equation, we follow the BODMAS rule. Bracket operation first, then division, then multiplication. Likewise, in MATLAB also we have to follow this rule. For example, if we have this equation, if you write it in this manner, it will give us incorrect answer. But if we incorporate this 2 plus 3 square in bracket, then it will first do the bracket operation, then one will get divided by, and then it will proceed further. But if you skip that bracket, then what it will does, 1 by 2 will get first operated, and then it will get added in the further, which will give us incorrect answer which we were expecting. So BODMAS rule we have to follow while writing the mathematical equation in MATLAB. That is very important thing you have to keep in mind. These are the other variables available. Answer will take most recent answer. Then infinity for INF, NAN. If we write 1 by 0, infinity, that is given by INF. If we try to find the inverse of a matrix which is a singular, in that case this NAN will appear. That is undefined numerical result. Then for pi, mathematical pi, pi is the alphabet we have to use. Then exponential function, exp in bracket. Then logarithm for natural logarithm, log. Whatever function you have to write, that should be in a open parenthesis. Then common logarithm to the base 10, we can write log 10 x. And for square root, inbuilt function is xqrt, and in bracket, whatever number of which you want to find out square root, you can write. Most important thing, vector operation. Vector is nothing but the one-dimensional array in a MATLAB. So we can write row vector as well as column vector. What is the difference? How we can write row vector in a matrix, in a MATLAB? We can separate the numbers either by giving a space or by giving comma, and then we can enter the row vector. As I told you, MATLAB is not available with me, otherwise I would have shown you how we can enter the matrix, how can we enter the row vector. And for column vector, what we are going to do? We are going to separate the numbers by giving a semicolon. Rather than space and comma, we have to give semicolon. It will give us the column vector. Then like in mathematics, we can add two vectors, we can subtract two vectors, we can have vector multiplication. How we can do that? We can reference the element. See, if we want to refer the element, what we can do? Suppose name of the vector is a v and there are these numbers in that vector. Suppose if I want to refer the third element of that vector, how we can do that? We can give the name of the vector and in bracket whatever element we want to refer, that we have to write in the open parenthesis. It will give us third element of that vector. Similarly, if we want to see all the elements, what we have to do? We have to give name of that vector, then in open parenthesis colon, it will list all the elements of that row vector. Then you can find the sub vector of that by using this command. 3 to 7. It will give element of that row vector varying from the 3rd up to 7th. Then these are the various vector operation which we can perform by using the MATLAB. Addition and subtraction of vectors, scalar multiplication of vector, transpose of a vector. For transpose just A prime, if you give, you will get transpose of that vector. Then appending vector, you can append vector by vector. For horizontal concatenation, what we have, and for vertical concatenation, what we have, that I am going to show you now. These are the other operations. Dot star. Simply instead of star, we have to use a dot star. What it will do? It will do element by element multiplication of two vectors. Then similarly dot division and then dot exponentiation, same function. What important things you have to take care of while using the MATLAB? If we are adding or subtracting the two vectors, as mathematicians know, they should be of the same size. You cannot add or subtract a row vector to the column vector. If you try to this, MATLAB will show that you have performed some error, some mistake. You can multiply or divide the elements of two same size vector term by term with the array operator dot star. This is a special operator in MATLAB for multiplication, not only simply star but dot star. But if we want to multiply any vector, row vector or column vector, we can use simple star. So these are the operations I have shown. A plus B, A minus B, transpose for that prime. Then you can take dot product of two vectors by using MATLAB. For that you have to use the inbuilt function named as DOT. Dot product of two vectors, just incorporate that two vectors in an open parenthesis by separating them by a comma. In every slide I am missing that MATLAB software. I would have shown all hand-on sessions for this. Then, like a one-dimensional array, we can write two-dimensional array, which we know, mathematicians call it as a matrix. Number of rows and number of columns. But what care you have to take? While writing the syntax, you have to incorporate the numbers in a square bracket for writing matrix. And what is the difference between row and the column? After completion of the first row, the second row you have to separate by giving semicolon. For example, if you want to write 3 by 3 matrix, then first row 1, 2, 3 element, for second row you have to give in between semicolon, then and then only MATLAB will identify that you are writing a matrix. You can refer the element, like we write A23 means it's a second row third column element. In the same manner, for MATLAB also you can refer the element of the two-dimensional array, that is matrix, by using this particular command, that 2, 5, and this A is the name of that matrix. Then we can refer, this command is for if we want to refer any specific column. Suppose I want all elements of the third column. Then for all elements I have to write colon, and then after that third column, that the name of that third column. In a similar manner, we can get the sub matrix by using the command that all elements from 2 to 3. So what it will give us? All the elements of second and the third column from the complete 3 by 3 matrix. So we can obtain the sub matrix also by using this particular command. Then we can delete even the row or column of a matrix. For that, this command is available. What you have to do? You have to give name of the matrix. Suppose you want to delete third row, all elements, then you have to write before comma 3 and then all elements given by colon. Similarly, in that case, you have to equal it to the empty bracket. It shows that you have to delete that particular row. If you want to delete all elements of the column, then now instead of writing after comma the colon, you have to write first the column and then after comma the number of column of which you have to delete the elements. Then you can concatenate two matrices, means you can concatenate horizontally also as well as vertically. So if you want to concatenate horizontally, what you have to do is you have to give, it will be again some matrix. So what you have to give, you have to assign some name, you have to write equal to, then in a square bracket, that matrix which you have to concatenate, first matrix A, comma, second matrix. Then you will get two matrices horizontally concatenated. If you want to concatenate them vertically, then in between two matrices you have to give semicolon. So these are the two ways of concatenating. See, this way we get horizontal concatenation and this way we get vertical concatenation. Then these are the various operations which we can perform by matrix like mathematical, and within a second it will give you calculation, matrix addition, matrix subtraction, division of matrices. Now you may be thinking how division of matrices get eliminated. It is actually performing A star B inverse. It obtained inverse of the matrix B and then that is multiplied by matrix A, and it is more faster than calculating A into B inverse. So this operator is very, very interesting. Then transpose of a matrix, just write A matrix you have entered already, give prime, it will give you transpose of that matrix. Then matrix multiplication, of course here that conformable matrices condition is there. You can multiply two matrices, those are conformable. Mathematical people might be knowing that M cross N, N cross P means first matrix column should be same as number of rows of the second column. Then and then only matrix multiplication is possible. Then you can calculate determinant of a matrix just by writing determinant and in open parenthesis that matrix of which determinant you need to calculate. Even you can calculate within a second inverse of a matrix. Just before that, to find the inverse, what you have to check? Already you have to calculate determinant of a matrix first, and if it is coming non-zero, then and then only you go for inverse. Okay, otherwise error will appear or NaN will appear in that matrix. So these are the operations A plus B, A minus B, A star B. Star is for multiplication. Then as I discussed just now that A by B will give you A star B inverse actually, and even you can verify whether MATLAB has calculated inverse properly or not. Just whatever A matrix you have entered and what after writing inverse in bracket A, you will get inverse of a matrix. Just take answer multiplication with A, you will find that it gives you identity matrix. Then there are some very interesting commands like EYEI. It will give you identity matrix. If you want 3 by 3 identity matrix, just write EYE and then in bracket write down 3. MATLAB will give you 3 by 3 identity matrix. Similarly, there is for null matrix, there is a command, inbuilt command, that is a zeros. If you want 4 by 4 null matrix, just write zeros and in open parenthesis 4, it will give you 4 by 4 null matrix. Then we can find the inverse as I told you by using the command, just write inverse and then matrix, you will get the inverse of that matrix. It is so simple and very interesting to find. Then determinant you can find. Now, actually yesterday I have almost hour together I sat and I have designed very interesting graphics for you, but that small mistake that my laptop fell down, I am not able to show you all those interesting graphs. Very colorful 2D, 3D graphs you can plot with the help of MATLAB, but I can give you what commands we can use for plotting the graphs. So plot creates a 2D line. We can have axis, we can change the axis, we can make it equal, we can change, we can give command to the axis as a minimum and maximum for y-axis as well as for x-axis. Then you can label the x-axis, you can label the y-axis, then we can put title for what we are plotting the graph, and then if we want, you can give print command to print the graph. So here I have shown you that we can, by using the parametric equation of the circle, we can plot a graph for circle by using MATLAB. But the first thing what you have to do, as I told you, matrix is the base for MATLAB. First of all, this 0 to 2 pi, this range we have to divide or we have to distribute in a array. Then and then only we can plot the graph. what command we can give that 0 to 2 pi range equispaced array, that I am going to discuss with you now. Just a second. This is the program or a syntax which I have written for drawing a circle with a unit radius. Why unit radius? You can see that your mathematicians know that x is equal to r cos theta and y is equal to r sin theta are the parametric equations for circle. Here you can see that r I have written 1. So first of all, we have to divide that, we have to create the array by using this linspace. What this linspace does, it equally distribute the 100 points from 0 to 2 pi. Initial 0, last point 2 pi, and in between 100 points which are equispaced. Now why 100? Because more the points, smoother the curve. If I take 50, my curve may not be that smooth. Then we can give x label, y label, and we can put the title, that is circle of a unit circle. If I would have shown hand-on sessions, it would be very interesting. This is the simple sin x plot. Again, you can see that every time your syntax start with the command that you have to split that whatever range has been given by using linspace. That is, you have to first create the array. Then we are plotting the graph between x and sin x. We have to label that x-axis will be having x, and on y-axis sin x, and title will be for created the graph. I have given that I have created this graph for conference. Then we can change various colors. I will show you what are the colors option available. See, these are the colors options available: yellow, magenta, red, green, blue, white, black. And the first letter we can use, if we want red color for the graph, we can write in a single quote R, and then whatever, if we want line, then these are the options available for line. Not only that, but some marker style options are also available, which you will find very interesting. If I write red plus, my graph will appear with a red color and all plus signs. If I write M, that is magenta, and the circle, that sin x graph will appear in a magenta color with the circles. So you will find then plotting graph is a fun if you use MATLAB and all the options available in MATLAB. Then not only single graph, earlier I have shown you that we can plot a circle or a sin x. Not only that, but with MATLAB, in a single frame you can plot more than one graph. So here I have given the syntax where we are plotting 3 graphs, that is of sin t, of a straight line, and these are the first 3 terms of the Taylor series. So all these 3 plots we can draw on a single frame by using a MATLAB. And to separate them or to identify them clearly, what we can do is, see, y1 I have not given any specification, because if we do not give any specification, MATLAB by default take blue color and a solid line. But if we mention the, see, here I have used the options. So for plotting y2, the second curve, I have given that line style is a dash dash. So second curve you will find after plotting that it, instead of a solid line, dash dash has been given. Then for the third, I have given marker circle. So when I will compile the graph with a run button, then you will find that we will, there in a single frame, 3 plots will appear. One with a solid blue line, second with a dash dash line with a color, and here I have not mentioned color, but before this dash dash line, if I write R, then it will take red dash dash line. If here in front of O, if I write G, that graph will be plotted in a green color with a circle notation. So you will find plotting graph by using MATLAB is a fun. Online help is available. Whenever you write in the MATLAB window, plot 3D, 2D graphics, it will give you some examples with which you can learn how to plot the graphs. Then title we can give. Then legend. When we have plotted 3 graphs in a single frame, I have to give a legend in a box where I can mention that red line dash is a graph for sin t, or the circle graph is for approximation. For that I can use legend also. We can either write one command for legend, or we can write it in the, when we compile, there is a window there, we can insert the legend. So two options are available for writing the legend. So these are the another options. So minimum and maximum axis, equal axis. These are the options available for axis. Equal, square, normal. If you don't want axis, you can write off in the, that will remove that axis, that outsider frame. Then you can plot 3D graph also, not only 2D, but 3D graphs also you can find. And it's a face to see those colorful 3D graphs, which again we have missed today. So here also, first you have to start with a array, and then I am using here mesh grid. This is a inbuilt function available for plotting the graph, mesh grid. And then the three-dimensional curve equation I have written here by using proper syntax for multiplication, division, for exponentiation. This is x, y, x square minus y square, x square plus y square. This is the division sign. And when I write mesh xyz and when I compile, I will get a beautiful 3D graph. This is another inbuilt function which I am using for plotting the 3D graph, and that is known as a surf. This surf, SURF, is again a inbuilt function for plotting the 3D graph. So with this we can plot, and there is a sphere 20. This function is already involved, inbuilt function. In that 4-dimensional array has been used, 3 dimension for XYZ and the 4th dimension for color. So when you use that surf XYZ, you have assigned to XYZ that is sphere 20, and then when you write surf XYZ, it will give 3-dimensional sphere with the colors. Very beautiful graph. Thank you. I'm extremely sorry. I have missed visual treat of graphs for you. Yes, sir. Yes, sir. After that, in a bracket, if after xy, if I write 50, then it will divide the array in a 50 points. Equispace 50 points. Linspace is the command, sir. No, sir. We have to first, the basis is array. So first of all, to plot the graph, we have to divide whatever is the interval span. That we have to divide in a equispaced array. So if you give maximum numbers, there will be, that I have that plots also. If I give 10 points, then random graph we get. If we increase the number, at some point that remains somewhat straight. But if we increase the number of points, smoother the graph we will get. That linspace is the only command we can use.
In Excel, actually it is done automatically. Give the command smooth graph, then it gives the automatically smooth graph.
No, sir. Here in MATLAB, as array is the basis, we have to define array. That is the only thing. Yeah.
If you have any questions, please ask. Please.
Yes? All research, all engineers, all mathematicians, all physicians, all researchers. Because matrices is required everywhere. I am teaching add-on course at LIT. Then my students of second sem, those who have learnt add-on course, they can use this basic knowledge and they apply this knowledge for solving equations of mass transfer and heat transfer, which sir is teaching. So they found it very interesting. And whatever results we are obtaining, see, for scientists and for researchers, whatever result we have obtained, whether is correct or not, that we can see if we plot the graph. For example, I am doing my research work on relativity and cosmology. We are finding various cosmological parameters. So I know that the energy density should be decreasing whatever model I find. So when I find the equation of rho mathematically, I try to find that graph for, if it is decreasing, I can say that yes, my graph is decreasing. So whatever model I have calculated is matching with the observations. So for researcher, MATLAB is a wonder. I must say it is a magic tool for everyone. At least science and engineers. Arts I am not aware about.
Okay, thank you, madam, for nice and wonderful lecture on getting started with MATLAB. As she has explained, we have this particular software for engineers and scientists. We are developing different mathematical models, and we are solving these particular models with the help of this particular MATLAB software. Other mathematical softwares are also available, but this is a wonderful tool, what she has explained. Thank you, madam. Coming to end of this particular session, I am thankful to all three speakers today. First one, Dr. G.P. Singh, Professor and Head, Department of Mathematics, who has delivered lecture on recent developments in cosmology. Then Dr. B.P. Bhaskar, Director, NBSS, Nagpur, for his delivering lecture, nice lecture on geospatial technologies in advancement of agricultural research. And Dr. Shiva Daudpure, madam, for her lecture on use of MATLAB for array and graphics. Thank you, madam. Thank you, sir. Thank you for the organizers for giving us opportunity, and I am thankful to my co-chairperson, Dr. Ganesh Kedar, sir, Head Mathematics. So I will hand over this session to. Okay. I forgot one more important thing. I request Kedar sir to felicitate ma'am with memento, shawl. Thank you, sir. Thank you, ma'am. I will hand over this session to organizers. Please continue.
Thank you so much, sir. Your leadership and active role made this session, sir, wait. Your leadership and active role made this session successful. I request Gajubhiye sir to felicitate our chairperson by certificate and memento. Okay. Okay. Thank you so much, sir. Thank you so much, sir. All oral participants are requested to upload their PPTs. Ha. Welcome to the session 10. The chairperson of the session are Dr. R.M. Zugade, Professor, Department of Chemistry, Rashtrasanta Tukloji Maharaj, Nagpur University, Nagpur, and Dr. Dhonde, Professor, Department of Physics, Mohta Science College, Nagpur. I request both chairperson to please come on dais. All oral participants are requested to upload their PPTs. Yeah. मैम हाँ पेस्ट करूँ तो The chairperson of the sessions are Dr. R.M. Zugade, Professor, Department of Chemistry, Rashtrasanta Tukdoji Maharaj, Nagpur University, Nagpur, and Dr. M.G. Bhonde, Professor, Department of Physics, Mohta Science College, Nagpur. I request both chairperson to please. Okay. Sorry. Dhonde sir, Professor, Department of Chemistry, Mohta Science College, Nagpur. I request both chairperson to please come on dais and occupy their seats. Now I request Smita ma'am to welcome our chairperson by giving sapling as a token of love and appreciation. Sir, session will hand over to you.
सर बसा अरे ठीक है अरे सर अरे
Sir, sorry, print
ओके
नासी कुठे आहे? हां हां ये
Okay, thank you very much. A very good afternoon to all of you. In this session, we are having one invited speech followed by a few oral presentations. In the beginning, we are having Professor S.S. Umbre sir from VNIT Nagpur as the invited speaker for this session. And I request the chairperson, Dr. Dhonde, to kindly welcome him with a sapling. It gives me an immense pleasure to introduce you to Dr. Suresh Umbre sir. He obtained his MSc in 1989 and MPhil in 1990, and subsequently he did his PhD in 1996 from our Department of Chemistry of Tukdoji Maharaj, Nagpur University. And he joined VNIT Nagpur, formerly known as VRC, that is Vishweshwaraya Regional College of Engineering, as a lecturer in 1996, and he is working over there. He got a full professorship in 2008 and subsequently Professor HAG in 2019. In 1998, he worked at Sheffield Hallam University, Sheffield, UK, under UK India REC bilateral project, and as a postdoctoral fellow at Department of Chemistry, IIT Kanpur. The research interests of Dr. Umbre are solid state chemistry of polymers, nanomaterials, heterogeneous catalysis, and green chemistry. With these few words, I request Professor Umbre to kindly proceed with his lecture for 25 minutes, followed by a question answer session of 5 minutes. Umbre sir, please.
Oh yeah, thank you. Okay, thank you. Thank you, sir, for kind introduction. My talk, it will be on climatic crisis and sustainable development. So we have several talk related to the soil,
sustainability, then ecological sustainability. Very good talk. And just like it is a sort of a, basically I can say, summarizing all the kind of the topic that we have covered so far. So in this lecture, okay, we'll be discussing about the scientific technological advancement, various environmental issues, and then climate crisis, sustainability concept and various approaches for the mitigation, then duties and responsibilities of the Indian citizens. We know today we are scientifically advanced country. We are economically advanced, technologically advanced. We have industrialization in 1970, 60, 19th and 18th century. Then we have a green revolution in 1960, 1970. Then we have a advanced material, green revolution. There is a lot of enhancement of the fertilizers, preservatives, and then pesticide in order to protect the food crop and then to feed the growing population. We have an advancement in the development of the different kinds of the material. The today's material, they can used at very high temperature, maybe at cryogenic condition, very low temperature, maybe very extreme environmental conditions. So many the materials that has been developed. Then we have a life-saving drugs. There are, we know our body temperature, it can be reduced by the drugs. Even it can be reduced the harmful diseases like cancer or maybe the tuberculosis or a tumor. And in a average lifetime in olden days, we have a hardly 42 years. But today we have average lifetime, it is 75 years because of the development of the new kinds of the drugs. We have a cosmetics and drugs, perfumes, and today we can go to the moon. Again, we can send our basically, to the Mars. So we have a lot of advancement, and these all advancement, it is because of basically advancement of the different kinds of the material. So we can say the material development, it has enhanced the quality and comfort of the life. If we see the other kind of a development, there is a excessive use of the fertilizers. Fertilizers are heavily used, and we know hardly 40% of the fertilizers is utilized. And excess fertilizer, it goes into the water bodies. The nitrate concentration is increasing into the water. Then excess, again, the pesticides we are using. We had a talk recently, the soil pollution because of the excessive use of the pesticide. It is coming into the food grain, the vegetable, fruit. The microbes, it is dying because of the heavy use of the pesticide. Again, a lot of the fuel that we are using, fuel, it is a carbon-based. And this carbon-based, when there is a combustion process, there is a emission of CO2 into the atmosphere. And we know CO2, it is a global warming gas, which is contributing to the climatic change. We are going to discuss about the various issues caused due to the climatic change, heavy use of the drugs. There are many drugs which are active in nature after consumption. And this is again somehow coming into the soil, coming into the water, and the different kinds of the sources. We have excessive use of, again, the coolant, the refrigeration application. We are using different kinds of the freon. And this freon, it is heavily used, which is contributing for the ozone depletion. So there are various kinds of the solvents again used. What is happening? Okay, so we see there are many reports coming into the newspaper. There is a excessive use of the pesticide, preservatives in order to preserve the food grain for a longer duration, prescribed by the WHO or maybe the BIS standard. And it is causing different kinds of the pollution. It is coming into the food chain and it causes the environmental pollution. It is bad to the, again, the human life. We have a lot of mining activity. There is a transport of, again, millions tons of the material from one place to the another place. And during this transport process, there is a, the flora and fauna, it is going to decay. There is a, yesterday we had a talk of Professor Khan, excellent talk. So some of the species, they are grow in that particular area And that species, it is dying because of this large amount of the mining activity. We have a deforestation, lot of the timbers that is using, lot of minerals that we are using, the different kinds of the mineral sources. And there is a basically the crisis on the natural resources. We have a 2/3 of the global population. They live under the condition of the and they serve water crisis at least 1 month in a year during the summer time. And 30% of the earth crust, it is already degraded as per the Forest Agricultural Organization, as per the report of the UN. And the lifestyle that has been changed, the today's lifestyle, we have a high energy consumption. Olden lifestyle, we know, we had a less consumption of the energy, but today we live in a air conditioner room, we drive the car, a lot of the consumption of the fuel that is we are using, and because of that, a lot of CO2 it is coming into the atmosphere, and which is causing the global imbalance at a global level and local level. We have a different global issues. The climatic change, it is a global issue. Then we have a ozone depletion, global warming, different kinds of gas it is emitting. We have a acid rain. The global warming, it is a basically international issue. One country may be emitting some of the pollutant, and the effect it has to be basically faced by the other countries. So it is an international issue. The local issues, basically air, water, land pollution, it is occurring. There is a loss of the biodiversity, ecological imbalance. We have a deforestation, lot of persistent organic pollutant, it is coming into the environment because of the different kinds of the human activity. Then again, the smoke generation. We have a poor air quality index, very poor air quality index. In some of the metros, we have a more than, it is 300 air quality index. It is poor to very poor in nature. And we know the basic fundamental for the development. Energy is the fundamental development, and our activity may be the transportation, maybe manufacturing, maybe heating or cooling, maybe shelter or electricity generation. For the various these sources, source is the fossil fuel. And fossil fuel, when it is burned, it is a carbon based, and CO2 it is emitted into the atmosphere, and we know CO2 it is a global warming gas which is contributing to the climatic change. And we know different kinds of the development, again the infrastructural development or basically the industrial development. There is a stress on increase in the GDP. We are basically, our government trying for $1 million of the economy. We are fifth, basically the largest country after maybe the America, China, Japan and Germany. So we are trying for a GDP. GDP means again we have to burn the fuel, increase in the energy rate. There is an increase in the population. The Indian population, it is 1.3 billion. And the world population, it is 7.8 billion. And for all these development, we are using different kinds of the fuel. In olden days, we used to use the biofuel. From 1815s, we started using the coal. Later again, coal and oil. Then again, there is an addition of gas. Now today, we are using coal, oil, gas, as well as the nuclear, hydro, wind, as well as the biomass and the solar. But the amount of the fossil fuel that we are using, still it is around 70%. So a lot of fossil fuel it is used, and we know. Okay. So, the fossil fuel, when it is combustion occur, we utilize the energy for the various application, and CO2 it is emitted into the atmosphere. CO2 it is a garbage. We know the garbage we are collecting in our home, in our kitchen, maybe hardly 3 to 4 kg, maybe in a week. But when we drive a car, when we burn 1 liter of a petrol, how much the CO2 it is going to emit? We can't able to see the basically CO2 garbage of the environment. But this CO2 it is garbage, it is accumulating in the environment, and we have a basically transition in shift from using coal to the diesel, then gasoline, then LPG, CNG, then the hydrogen. Basically, we are going towards the hydrogen and reducing the carbon percentage. We have a the carbon percentage is very large in coal, diesel, gasoline. LPG, it is reducing, carbon percentage is reducing, and the hydrogen, it is a green fuel nowadays. It is using in most of the advanced countries. We know this is a basically atmospheric CO2 concentration. It is continuously monitoring by this Mauna Leo laboratory, and there is a rise in the continuous rise in the CO2 concentration. Now this is the concentration of the CO2 in 2020. It is 417 ppm. China is the topmost country which are emitting CO2 into the atmosphere. Next come the United States, and India, this is the third most country which is emitting CO2 into the atmosphere. We know the CO2, there are many gases. CO2 is one of the gas which is a global warming gas contributing to the global warming potential, global warming and climatic change. Apart from that, there are large number of gases which is contributing to the global warming. But we are bothering more about the CO2. Basically, the CO2 concentration during pre-industrial period, it is hardly 280. And today, in 1998, it is 365. Today, it is 470. There is a rise in the CO2 concentration. For other gases, the CO2, the concentration of the other pollutant, they are less. Greenhouse gas, it is less. And we talk about the basically lifetime. The lifetime, it is very high for CO2. The global warming potential is 1. Though the global warming potential for CO2 is 1, the global warming potential for other greenhouse gases are high. But because of the atmospheric lifetime, it is 100 to 300 years. Whatever the CO2 it is emitted by our maybe father or forefather, it is still remaining in the atmosphere. And whatever the basically the activity done by our father and forefather, we have to face the consequences. Similarly, whatever the the activity we will be performing, that CO2 it will be remain in the atmosphere for another 300 years, and it has to be faced by our children, maybe the grandchildren. So we have to think of how much CO2 that can be basically utilized. Okay. Okay, so we know the carbon cycle basically. So carbon cycle, we know the carbon cycle, basically carbon it is transforming from the atmosphere to the soil, and again it is coming to the atmosphere. This is the basically CO2, it is absorbed by the plant, and we consume, the animals are consuming the plant, and the food again it is coming to the body of the animal and plant, and when this the animal they die, again carbon goes into the soil, and by our respiration process again CO2 it is coming into the atmosphere. We know we are consuming, we are taking the lunch, maybe in the morning, in the breakfast, then lunch and the dinner, and we are emitting CO2 in the form of a respiration process. Around 140 gram of CO2 it is emitting every day by individual person. So we can calculate the amount of CO2 emitted by India. We have a 1.3 billion population. The amount of CO2 emitted by the country and by whole world. So the CO2 concentration, absorption capacity now it is decreasing. We have a deforestation. We are converting forest into the agricultural land, maybe the residential places because of the increase in population. So the absorption capacity is increasing, and CO2 concentration it is continuously, absorption capacity it is decreasing, and CO2 emission it is increasing. CO2 concentration, it is 2020, it is 470. So what are the consequences of this? Basically, the consequences of the CO2 concentration. Okay. 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 So there is a rise in the temperature of the earth crust. We called it as a climatic change. There is an increase in the rise in the temperature of the earth crust. We know our average body temperature. it is 37 to 38.2 degrees centigrade. It is nearly coming out to be 99 degree Fahrenheit. If it is, there is a rise in the 1 degree temperature, we know we say we have a fever. Fever means we have our metabolic system get disturbed. We cannot sleep, we cannot work. And what will happen to the basically earth if there is a rise in the temperature of the earth? So metabolic system, basically the ecological system of the earth, it is going to disturb by increase in the temperature of the earth because of this rise in the CO2 concentration and the global warming effect, different kinds of the effect. And the consequences, it will be the flood. We have a lot of flood. We have yesterday a lot of rain. Last week, again last month, we have a heavy rain in the Bangalore, the Silicon Valley of our India. It is flooded. In summer again, in Odisha, basically we have a summer. In Delhi, we have a very high temperature, maybe around 49.2 degrees centigrade. And in Assam, we have a heavy flood. It is not only the India, but the whole world, the China, it is affected with the flood. Even the USA, it is affected with the flood. There is again, due to rise in the increase in the temperature, there is a melting of the ice cap. Where this ice cap, there are many the animals. It is living in the that ice belt, polar ice cap. So the reindeer or the bears, they are going to affect the life of their the bear and reindeer. It is going to affect. So we know there is some glaciers and a lot of glaciers. It is formed, and the millions of years ago there is the virus. It is get buried in that particular what you call the glaciers. And these glaciers, if they are melting, the virus it will be coming into the atmosphere. And we don't know how this kind of a virus, new virus, it will be basically behaving once it is coming into the atmosphere. From last, 2 years, we are basically struggling with the managing the coronavirus. That is of the known family. And if it is of unknown family, certain virus, it will be coming. We don't know the consequences of it. We know there is a rise in the sea level because of the melting of the ice cap, water, it will be goes into the sea, and it is get affected. The 3.3 millimeter of there is a rise in the sea level per year. This is the city, Jakarta city of Indonesia. It is flooded. It is like a submerged. We know the ocean. Ocean, it is a big, it is a huge, we can say it is infinite. But this is, due to this rise in the sea level, this is the city Jakarta, it is submerged. So we have again storm. We know the frequency of a storm. It is very less in the olden days, but now there is a rise in the frequency of a storm because of again increase in the temperature, global temperature. We have again, the forest fire. There is a rise in temperature, reduction in the moisture of the moisture in the atmosphere. It catches fire. Basically millions of the kilometer square area, it is get affected. We have a California forest fire. We have a Russia forest fire the last year. So there is a basically forest fire. Means again there is a burning of the basically forest. CO2 it is coming into the atmosphere. There is a burning of the animals. Again it is going to affect the ecosystem. Now there is a heat wave. Again there is a rise in the temperature. Heat wave we have last time in Delhi, May. We have a temperature of 49.2 degrees centigrade in May. This is the Canada city, the Lighton. This is the city. It has a temperature of 49.6 in 29 June 2021. So there is a high temperature where cooler is not going to work. Your AC is not going to work. So this is a high temperature. It is created because of all the human activity. There is a drought. Again, there is a reduction in the surface water. The drought is creating, there is no, again, the vegetable that is going to grow. We know the air quality index, it is very bad in some of the metros. Delhi, it is poor to very poor in all the year, throughout the year, except few months, it is very bad. And, due to the effect that the respiration process, it is going to affect. And we have the asthma, or the child or the old age people, it is going to affect.
And many people say Delhi is not a livable city. So many people, they are shifting Delhi. They are not basically living in the Delhi. No, this is a cartoon. It says basically the interaction of the parent and a child, a son and a father. Basically, we have a basically custom to accumulate the wealth, so that wealth, these our children, they can utilize during their difficult time. This children is unable to breathe the natural air, and father is offering some wealth, which is of no use to him. So basically, this talks about the pollution of the environment and how we can tackle these basically different kinds of the environment. So who are the creator of this problem? All these issues, it is created by the ourselves. All human activity, human species, it is basically, is the ever evolved species in the world, and we are the problem creator. And who will be the part of the solution? So we are the part of the problem. So we are supposed to be the part of the solution. We are inhabitant on the earth. So it is our responsibility to maintain the climate on the earth. So we have a, basically, this is a quotation of Dalai Lama. He is a monk. He is a Tibetan monk. And he says, we are the generation with the awareness of a great danger. We are ones with the responsibility and the ability to take step of concrete action before it is too late. Who will be initiating the concrete action? Because you are the young generation, and this is the basically responsibility on your shoulder. One has to find out the basically solution. You find out the technologies in order to tackle the different kinds of the issues, environmental issues. We know our Constitution of India. The Constitution of India, it is given some right. We know everybody, the right of the freedom, right of the religion, right of equality, different kinds of the right, we are all aware. And if something goes wrong, what we do? We start agitating, we start Murdabad, Jindabad, right? So again, what about, we know all the fundamental duties given in the rights given in the Constitution. But what about the fundamental duties? The Constitution has given again the fundamental duties. The fundamental duties, basically, the Constitution, Part 4A, Article 51A, Clause G and H, it talks about basically the natural environment. To protect the natural environment, and H clause, again, it talks about the scientific temperament. So one has to increase the scientific temperament among the people of the country, as well as one has to improve the natural environment. It is our duty. Apart from these two duties, there are again other duties. We know we are all above 18. We have the right of basically vote. So at the same time, one must have a basically what are our duties. One must understand the duties, our duties. So sustainable development, it has come into the picture by using this environmental basically protection and the duties. We have to perform the duties, improvement of the lifestyle and well-being by preserving the natural resources and ecosystem. That is nothing but basically the fundamental duties. The UN initiates to tackle some issues. We have a in 1972 we have a first UN conference at Stockholm on the human environment. The people started discussing about the environment. In 1990, US Congress established Pollution Control Act. Then in 1992, there is a first Earth Summit, Rio de Janeiro in Brazil. And it come out with some outcome. Outcome, that is the Agenda 24, that is the action plan, which is a blueprint for the sustainable development for 21st century. Then it comes into the force in 1994, the United Nations Framework Climatic Change Conference, and to achieve the basically stabilize the greenhouse gas into the various countries. Now there are some scientific agreement like the Kyoto Protocol. It talks about basically to establish the greenhouse gas concentration, and it has come into the action in 2005. Developed countries has to reduce the CO2 emission by 5.2% during the period of 208 to 212. Then we have a Doha Protocol to reduce again the greenhouse emission by at least 18% below 1990 level. We have a Paris Agreement again in 2016 to keep the global temperature rise below 2 degrees centigrade. Why 2 degrees centigrade? Basically, there will be a catastrophe that is going to occur if there is a rise in the temperature above 2 degrees. The scientists were predicting. So we are trying to reduce the temperature, maintain the temperature of the earth below 2 degrees centigrade at the level of our industrial period. Now, this is the scientific agreement and the initial initiative, India's initiative to limit the emission intensive per unit GDP by 33%, 33 to 35%, and India is aiming to reach 40% of the installed capacity via non-fossil fuel. India is going to increase the forest cover to absorb the 2.5 billion ton of the CO2. So there are different international protocol. At the same time, there is some scientific approaches to the climatic mitigation. Nowadays, there is a use of again, the solar, so that the CO2 emission, energy CO2 that can be generated, energy that can be utilized, and there will be reduction in the CO2 concentration into the atmosphere. One has to shift our dependence from the fossil resource to the renewable resource. We know the renewable resource, that is the plant resource, the biomass. If we, instead of using the fossil fuel for as a energy source or for the different application, maybe for product development, different kinds of a product development, if we convert this biomass into maybe the fuel, maybe biofuel, biodiesel, maybe the ethanol, maybe disol, gasol, different kinds of the biofuels are there, and the carbon concentration it is going to maintain. There will be no thermodynamics imbalance into the atmosphere. Whatever the basically biomass, carbon it is converting into the biofuel. Biofuel it is used, again it is emitting CO2 into the atmosphere, but we assume whatever the CO2 it is emitted by burning of a biofuel, again it is absorbed by the biomass, and by that way there will be no net rise in the CO2 concentration into the atmosphere. So this is the petrochemical route. We have a industrial biotechnological route. So we can say, for fossil fuel generation, it takes millions of years for its formation, and we are utilizing this fossil fuel within a few decades. But if we convert this biomass into the fuel, maybe biofuel, and this biofuel, it can be, if it is utilized, there may be increase in the CO2 into the atmosphere, but again the biomass that can be grown, whatever the CO2 it is emitted, it can be absorbed by the biomass, and there will be net, there will be no rise in the temperature of global CO2 concentration into the atmosphere. There are some energy efficient technology, many nowadays we are using, that is a microwave technology. It is an energy efficient technology. Microwaves are utilized, there is a energy generation, and that energy it is utilized for a microwave synthesis, and many industries nowadays it is using microwave synthesis as an energy efficient process. Again, this ultrasonic process that is used for synthesis of the many product in the industry. We know the catalytic process. Catalytic process, it is basically energy efficient process. We know Haber process. It is a high temperature, high pressure process without catalyst. But if we use a catalyst, there is a tremendous decrease in the temperature and pressure. So it is an energy efficient process. So one can utilize the catalyst so that the energy utilization basically it get reduced. Now we'll talk about basically, there is a functional material. We called it as a semiconductor. And the tree are basically, absorbing the CO2 from the atmosphere and converting into the biomass. We get the vegetable and fruits. It is basically a green process, photosynthesis. We called it as a green process. Nowadays, the scientists are using the term
artificial tree. Basically, this is the term used by the scientists for a semiconductor. Semiconductors, they are basically functioning just like a tree. They are absorbing CO2 and converting that CO2 into the useful product, maybe methane as a product. Yesterday we had a talk, and there is a synthesis of a CO2, conversion of a CO2 into the methane. CO2 can be again converted into the different kinds of the chemical, useful chemical, maybe the alcohol or the the formic acid, different kinds of the useful chemical that can be utilized. And this semiconductor, basically, it when it is utilized, the visible light active semiconductor for a photocatalytic application, one can split the water into the hydrogen, one can have a green hydrogen. Again, this semiconductor can be utilized in order to convert the nitrogen into the ammonia. This is a Haber process, it is a high temperature process, but conversion of nitrogen to ammonia, it is basically a room temperature process using a semiconductor, different kinds of a semiconductor. One can utilize this semiconductor for the inhibition application, bacterial inhibition application. There is a generation of electron and hole. That electron and hole basically they kills the bacteria. It is used for again the the cell cleaning application. It is called it as a cell cleaning application. So this is the basically some of the work that we have done in our laboratory, synthesis of the graphitic carbon nitride, phenyl doped graphitic carbon nitride. Okay, just I will finish. Yeah, and there is a we have basically utilized in order to convert the CO2 into the useful product like the methane, methanol, and the formaldehyde. And the CO2 basically, olden days we cannot imagine basically the use of a sunlight for converting it to the energy. But we can, today we are using it, sunlight, for converting it to the energy. So we may run our car, maybe CO2 in future, maybe after 100 of years. If we have a closed reactor, the CO2 can be converted into the fuel, maybe the methane or methanol. And using this methanol and methane, one can run our car. So maybe in future, maybe after 100 years, the technology can develop and one can run a car on a CO2. This is another molecule that has been developed which can be used for a super capacity application, charge storage application, which is having a high capacity compared to the original product. Again, the rechargeable, the lifetime, it is more. This is another again molecule which is used for degradation of the different kinds of the pollutant, the dye pollutant, maybe the pharmaceutical pollutant, different kinds of a pollutant. It can be utilized. This is again used for basically the microbiological inhibition application. One has to modify the basically existing process. The Bhopal gas tragedy, there is a use of the methyl phosphine as one of the intermediate. Now there is a development of a process, and in a process this phosphine that has been removed and separate process that has been developed. So one has to modify the process. Now the prevention of the waste, the normal process, the reactant converts to product and byproduct, and product, byproduct, it is become a waste. Product, whatever we generate, it may be a tonic, maybe a vitamin which can save the life of a patient. But at the same time, there is a generation of a toxic byproduct which can kill the patient. So one has to work for a process where there is no generation of the waste. This is the Nobel Prize of 2021 given to these three physics people. They have worked on the weather climatic modeling and the human effect on a global warming. Basically, we are doing all the scientific activity, but only scientific approach for climatic mitigation may not going to work. Heavy consumption, human greed is the basically fundamental cause of the pollution, ecological imbalance, and the climatic crisis. There is a quotation of the Mahatma Gandhi, our great leader. There is enough on the earth for everybody's need, but not for everybody's greed. Basically, our greed, it is increasing. The consumption, it is very high. And the technology,
it is not going, it is becoming helpful. You know, we have a development of a hybrid car, which is an energy efficient car. The people are buying it. Government is giving some subsidies. But at the same time, people are buying it, and they are planning more and more journey. So consequently, effectively, it is not going to work. The scientists are developing some technology. At the same time, we have to modify our behavior. We have to conserve the water in a scientific way so that it will be utilized properly. Again, we have to shift our dependence from the private transport to the public transport. You know, this is a one car, one bus which is accommodating 70 people. We have a 70 vehicles. We can assume, we can imagine what is the amount of basically fuel consumed by the 70 car. The fuel consumed by the one bus. Again, emission emitted by the 70 car. Again, the materials required for the manufacturing of the 70 car. Maintenance of the 70 car. Basically, so a lot of, again, the material consumption one has to reduce. So this is a quotation of our great, past president, late Abdul Kalam. Luxury and life have a huge maintenance cost, but truth and simplicity are self-maintained without cost. So be a part of the solution, and I will end my talk with the quotation of this American radio speaker and author, Earl Nightingale. He basically worked on human character and development. Basically, he says our environment, the world in which we live and work, is a mirror of our attitude and expectation. So one has to basically modify our expectation. The consumption has to be reduced. We have to modify our behavior, and basically the attitude has to be changed. So with this, I thank you. I thanks to the organizer, Professor Gajbiye, my teacher, and Dr. What is Acharya Madam. Sorry, Acharya Madam, for kind invitation. So thank you.
The CO2 emitted by us today will affect my 3 generations. So we are a part of the problem, and we must be a part of solution too.
Yeah.
Excellent talk, sir. Thank you very much for the nice, informative lecture. Now I request Dr. Dhonde to kindly present a memento and a certificate to Professor Umbre, sir. For any queries, questions, etc., we can discuss with Umbre sir after the presentations during the lunch session. So we will immediately start with the oral presentations. For this, I hand over the mic to Dr. Dhonde sir.
Good noon, all present here. Honorable invited speaker, Honorable Dr. Gajbiye sir, respected Acharya Madam, respected judges, and all professors of various departments, I warm welcome to this session. In this session, first I invite to respected Umesh Palikundwar sir, Department of Physics, Dr. Vandana Samant from Department of Geology, and Dr. Rupesh Badere from Department of Botany, ITM Nagpur University, Nagpur, are judges for the oral presentation. Okay. Dr. Professor Das is a Department of Chemistry, VNIT, Nagpur. I personally warm welcome to all of you. The rule for this oral presentation, in this session, 5 oral presentation are there. Name is Dr. Vijay Tangade sir, second is Sushma Giribunje, third is Suvarna Saude, fourth is Pragati Jibkate, and fifth is Dr. Kavita Apkazi, right? All the research scholars are informed that you must aware of the marking of oral presentation. Okay. For the judging your oral presentation, 3 experts are there. Okay. Result of the presentation based on the marking system. Full and final decision will be taken by the expert. Okay. This is very transparent system. Only 8 minutes of every participant. Okay. Before 8 minutes means one warming bell before 2 minutes. Okay. You have to finish your presentation. Okay. Otherwise, last bell to stop your presentation. After complete your presentation, session will be open for discussion. First, judges will ask the question and give the suggestion if any. Subsequently, session is open for the audience. Okay. The result will be declared after the all presentation combined, and finally the name of the best oral presentation will be announced in the validity function. Okay. So I request to judges, please come on the front. First I invite Dr. Vijay Tangde sir.
Shall I start? So, good afternoon to one and all. Respected chairman of the session, Professor Zugade, Professor Dhonde, respected judges of the session, and dignitaries of the dais, and my dear friends. I am presenting the work based on solvation behavior of some pharmaceutical drugs in aqueous, dextrose, and urea solutions at a various temperature range. And this is a work performed by my PhD student, and I'm going to give the glimpse of what we have performed during this work. Basically, why we have studied this particular work in dextrose and urea is their concentration in biofluid is comparably it is comparable to the biofluid, and their interaction with the amino acid, various amino acids and pharmaceutical drug, it is that way important to give the idea about the molecular interaction. So the drugs which we have taken for the study were creatinine, which is the eliminating product of renal secretion and byproduct of muscle metabolism produced by kidneys. The other drug is ornithine monohydrochloride, and the third drug is citrulline. So we have taken all the 3 drugs and their combination in aqueous medium, in urea, and in dextrose. Their biological relevance is because of their relevance in urea cycle. They are readily soluble in water. This is one of the reasons why we have chosen these compounds, and their molecular interactions are good with respect to dextrose and urea. And apart from that, these drugs, the molecular and thermodynamic interactions of these drugs were not seen in the literature. This was the major reason why we have chosen these kind of studies. These are the types of interaction which we are intended to study during the experimental observations. These are the cases where we have tried to apply. This particular part is of creatinine, and we have studied 3 systems with creatinine. One with aqueous system of creatinine, other these aqueous creatinine in dextrose medium, and aqueous creatinine in urea medium. The entire concentration range was taken from 0.02 to 0.2 mole per kg, and different parameters like density, sound velocity, are experimentally observed and their derived parameters have been measured. The similar work has been done with ornithine hydrochloride and then citrulline. All the three work, they have been published in good journals. This is in ACS JCED. The second work is published in Journal of Chemical Thermodynamics Elsevier, and the third one is published in Chemical Thermodynamics and Thermal Analysis. These are the instruments. This is a basic instrument which we have at our laboratory. This is DSA, Density Sound Velocity Meter, and this robotic arm is a viscometer, which this study has not been included in this presentation, but then this is a viscometer, and this instrument has been utilized. This is a vibrating tube densimeter, and these are the thermodynamic parameters. What we have done, we have compared our results with the literature, and we found that the values which we obtain in our case, they are matching very well within the limits of uncertainty in all the cases. These are the values for experimental density with the literature for dextrose and urea. These are the values of speed of sound for dextrose and urea. These are certain thermodynamic parameters which we are observing. Basically, we will come to this point. Apparent molar volume values, these are very important for us to calculate these values based on the density measurement. These values gives you the opportunity to see whether there is any kind of hydrophilic, hydrophobic, or hydrophilic or solute-solvent interactions are there present or not. So these are apparent molar volume. And for electrolyte, we have used Masson's equation, and for non-electrolyte, we have used Redlich-Mayer equation. Uncertainty also we have calculated, and this is very well within the limit of good uncertainty. We have found that if we consider the uncertainty of density of 0.05 kg per meter cube, what we have got is at lower concentration it is about 2.5 ml, and at higher concentration it goes to 0.25 ml about. And then we have used empirical equations to calculate the further data, that is expansivity and then Hepler's constant, that will help us in understanding the structure breaker and structure maker ability of the drugs. So accordingly, we have seen the acoustic properties, and there are certain parameters like compressibility of the water solute in and around the drugs, and we have also seen the compression nature, apparent molar compression nature of the drugs. Also, we have calculated the hydration of the solute, and we have analyzed the complete data. These are all the results which we have plotted in graphs. It was not appropriate to present all the data here because it was a huge data, and therefore we have taken some of the graphs, the glimpses of density data for each of the compounds we have taken over here. These are the plots of apparent molar volumes. This basically gives us an opportunity to study the solute-solvent interaction with V5, and if I have a positive slope and the values are increasing with the temperature, I can confirm that there is a good interaction of solute and solvent. These are the plots in all the three cases which we have obtained. Then we could obtain the transfer values. Again, this confirms the hydrophilic interactions in our all compounds, and therefore we could conclude that yes, there is an interaction of urea and dextrose molecule with all the three pharmaceutical compounds, and therefore it confirms well with their interaction. All these are the graphs, acoustic graphs, the speed of sound graphs. The values are well within the uncertainty what we have claimed. The isentropic compressibility calculations and their graphs are reported over here in case of all the three compounds. It is actually skipping. So this is the compression values, and this compression values gives us an opportunity to see how, up to what extent your water molecule is compressible in the vicinity of your solute, and therefore if these are the values which we could get. In case of this interesting result we have got in this ornithine, the values of V5 and now in K5, we could see that there is a formation of critical micelle concentration, and this can further be studied by surface tension studies. However, this has not been included into this study, but then these compounds have shown this kind of behavior also. Hydration number, we have used two methods, Passenski method and Shio's method, and we have tried to find out their interactions, and these are their behavior. Yeah, I am done with it, and therefore these are the volumetric results which I have already discussed. Thank you.
Any questions from the judges?
And dextrox.
Yes.
So, I particularly wish to know why urea and dextrox, because drugs has to be consumed by the humans or any living being.
Yes.
Is there any relevance
Yes.
with that?
Yes, because biological fluid contains their concentration of particularly glucose and urea in the range of say around 0.05 molal or 0.06 molal, and therefore particularly if you see, we have carried out this study in 0.06 molal dextrose and 0.06 moles per kg of urea, and that somewhere mimic the biofluid concentration of urea and dextrose, because creatinine, which is as a byproduct of your renal activity, and therefore we thought that studying creatinine in urea would be good, and studying, because glucose has got relation with the digestive system, and both the things are coupled reactions. The combustion of glucose and generation of urea are coupled processes, and therefore we thought that this would be interesting study to study these kind of drugs which are little bit relevant to the amino acids, and therefore we have taken these systems. Otherwise, we could have also studied in NaCl, KCl, or MgCl2. But then since these were pharmaceutical drugs, we thought it is a good idea to study it in
exactly
some salts which are mimicking the biofluids.
Okay.
Yes, sir, moles per kg. Weight. Yes, sir. Otherwise, it will not give me the opportunity to calculate its specific uncertainty. In case of, since we take its weight, we do not have such a system in which volume is taken so precisely, whereas you can weigh weight up to 5th decimal place, and therefore we can extend our uncertainty of measuring density up to say 6th decimal place or something like that, and therefore since we are studying the parameter like apparent molar volume, it goes up to 6th decimal place of the decimal, and isentropic compression, it goes to 15th decimal place of your decimal value, and therefore it is always good that we should have data which will give you the more precise value up to say, it gives me a possibility, because I have in my laboratory the balance of Salterius, which gives me reading up to 5th decimal place. So I get opportunity to go get my results more precisely. That is what is the reason. Thank you, sir.
Thank you, sir. Next, research scholar, Sushma Giripunje. The topic is the photocatalysis performance of ZNAL, layer double hydroxide nanoparticle in the removal of methyl orange dye. Next, Dr. Suvarna Saude. Quinoline drop aluminum cumarolated, a possible candidate for the PC LED application.
Good afternoon, everyone. I am Suvarna Saude from Priyadarshini College of Engineering, Nagpur. Today my topic is quinoline doped aluminum cumarinolate, a possible candidate for PC LED applications. A phosphor coated LED consists of a blue LED on which a phosphor that can be excited by blue light is coated. The emission of the phosphor in green-red region gives either a green LED or a red LED. If the emission is broad, ranging from a green region to a red region, then LED gives you white light. Several inorganic materials such as YGC, CZ, CS, EU, K2 SiF6 Mn have already been developed and are used in LEDs. So in this work, we have used the coumarin as a base moiety and quinoline molecule as a dopant. It is well known that some organic molecules exhibit luminescence. The luminescence is quite weak, but it can be enhanced by forming chelates with metal ions. So this is the synthesis method, that is a flow chart that we have shown here. That is, we are taking coumarin and quinoline. We are mixing the two solutions and it is mixed with the aluminum nitrate solution which is dissolved in distilled water. And we have added the NaOH pellets so as to maintain the basicity above. That is, we have to maintain pH above 7 so that a precipitate is obtained, and then whatever the precipitate is obtained, we have filtered it out, and then we have dried it under the conventional lamp for several hours, and then the sample is sent for testing purposes. These are the results, that is the XRD. The figure A, it shows the XRD of the purchased pure coumarin. And this XRD, it matches with the diffraction pattern reported in the ICDT database file number 0110704. The figure B, it shows the XRD of AL coumarinolate, and this XRD is entirely different as compared to that of the pure coumarin. Then in the third figure, we have shown that it is the XRD of aluminum coumarinolate doped with 5% of quinoline, in which we can see that this XRD is entirely different as compared to the first two XRDs, that is of pure coumarin and XRD of AL coumarinolate. The quinoline and the additional lines are observed here, which indicates that the additional lines, they are of the pure quinoline. It means that the pure quinoline has well incorporated within this coumarin moiety, and thus altogether a new compound is formed here. This is showing the PL of aluminum coumarin based chelates, in which we can see that the pure coumarin, it is having the emission band at 400 nanometer with a broad excitation band at 385 nanometer. And when we form the aluminum coumarinate, we found that the emission, it is shifted by 100 nanometer, that is, it is observed at 500 nanometer with a broad excitation band which is centered at 400 nanometer. Thus, the luminescence of this aluminum coumarinolate not only changes the position of the emission, but it also changes the emission intensity. This is the PL LED spectra of some aluminum coumarinolates doped with quinoline. We can see here, as the percentage of the quinoline, it is increased, every time the intensity, it goes on increasing, and it is found that for AL coumarin 60, quinoline 40, the emission is found to be highest. So this opens the possibility of using these complexes as white phosphors in PC LED applications. This is the thermal analysis of AL coumarinolates doped with quinoline. We can see here that as the percentage of quinoline is increased, every time the thermal stability, it goes on increasing. That is, the decomposition is delayed. So this is the conclusion, that is the AL coumarinolate. It shows well-defined XRD peaks, which suggest that all the complexes, they are crystalline in nature. Addition of quinoline, it introduces the amorphicity in the complex. The aluminum coumarinolate shows relatively intense luminescence compared to pure coumarin. The emission and excitation was found to be red-shifted compared to pure coumarin and is observed at 500 nanometer and 400 nanometer respectively. The aluminum coumarinolate shows intense luminescence compared to pure coumarin. The emission and the excitation was found to be red-shifted compared to pure coumarin and is observed at 500 nanometer and 400 nanometer respectively. Adding quinoline in small amount, it affects the emission and the excitation of the AL coumarin significantly. In most of these coumarinolates, the emission is observed in the blue-green region with the excitation shifted doped in blue region. Of several samples, sample doped with 40% quinoline, it shows most intense emission. Intense emission along with good overlap of excitation with near UV to blue emission of GAN best LED. This phosphor will find applications as white phosphor in PC LED applications. The thermal analysis of aluminum comorillinates doped with various amounts of quinoline shows better stability as compared to pure sample. So these are some of the references. Thank you. Yes, sir.
Incorporate some schemes showing the molecular structure. And what is the pH? Have you checked the pH of your medium?
pH is maintained above 7 so that a precipitate is obtained. Pardon? Actually, when we are mixing 3 solutions, no, sir, we are not getting a precipitate. When we add NaOH pellets to the distilled water, say 1 normal, then only we obtain the precipitate. We can check the basicity with the help of... But it has to be greater than 7, then only we will obtain the...
What is the unit in TGA y-axis?
What is what? Unit. It is TJ, it is mg, and temperature it is degrees Celsius. The temperature is increased. See, sir, the phosphor is likely to get heated whenever we heat. Yes, it has to be in percentage. Means there are some endothermic peaks and the exothermic peaks. The weight loss is shown with the red line. The weight loss is shown with the... Yes, that is in mg. That is weight loss in mg. Okay. Okay, but we have found out the percentage also. Okay. Okay, okay. Thank you, sir. Thank you, ma'am.
Thank you. Next research scholar, Ms. Ujjwala Rahate, phytochemical study.
Ujjwala Rahate.
That is a new addition actually.
Yes, sir.
Good afternoon to all. My name is Ujjwala Rahate and I am going to deliver my oral presentation on the topic of qualitative phytochemical study of Cassia sophia aquaethanol seed extract. Under this title, the contents are introduction, methods and material, observations and results, discussion, references and acknowledgement. First of all, introduction. Medicinal plants have produced the modern medicine with the numerous therapeutic agents. Many plants include a variety of phytopharmaceuticals which have a significant uses in human, veterinary and agricultural medicine. Natural products are crucial in the development of novel medicine, leads to treatment and prevention of diseases. The plant Cassia sophia comes under the family Caesalpinaceae. It is also known as Kasundi in Hindi and Senna sophia in English. The Cassia sophia has been great potential uses, especially as a traditional medicine and pharmacopoeic drug. Cassia sophia used for the treatment of anti-inflammatory, anti-diabetic, anti-asthmatic, hepatoprotectivity, and anti-allergic activity. The several phytochemicals present in the plant, such as free carbohydrate, proteins, saponin, tannin, terpene, phenol, flavonoid, and alkaloids. Next one is materials and method. The plant material collection and authentication. It is an evergreen shrub found in all over India and other South Asian countries. It is found on roadside, wasteland, and in the forest. The plant material was collected from the hygienic places from Parat Singha village, Nagpur district, Maharashtra, India. The GPS collected this plant recorded is 21 degree 19 minutes 37.848 second north side and 78 degree 31 minutes 12.492 second east side. After making a herbarium leaflet, the plant was proceeded for identification and authentication was carried out. Department of Botany, RTM Nagpur Institute, Nagpur. Reference number is given by them 10196. This is the images related to study collection of the plant, then overview of the plant and this herbarium leaflet of the plant. Preparation of extract. The plant material collected and washed it well and dried up to 5 days after drying the seed, ground it with the help of electric grinder. Powder of seed used as a sample 500 gram each well. First extracted aqua ethanol of equal proportion of the water and the ethanol at 80 degree to 90 degrees Celsius using Soxhlet apparatus. Each extract was concentrated by keeping it overnight at 50 degrees Celsius. The color of this extract were recorded and proceeded for the further detail for phytochemical screening. Preparation of the extract. These are the first image is showing the seeds of extract and second image is showing the extract of Cassia sophia. Observations and results. Failing test used for identification of the carbohydrate compound. The brown color is obtained. It means that it is confirmed that the presence of carbohydrate in Cassia sophia seed extract. Second test is for Salkowski test used for identification for the terpenes compound. The two layer is formed, upper layer and the lower layer is formed. It means that it is confirmed that the presence of terpenes in Cassia sophia seed extract. Third is ferrichloride test used for identification for the tannin compound. Black color PPT is formed. It means that it is confirmed that presence of tannin in Cassia sophia seed extract. Foam test used for identification for the saponin compound. The white bubbles present at upper surface, it means that it is confirmed that presence of saponin in Cassia sophia seed extract. Lieberman-Burkas test used for identification for the terpenes compound. The brown color is obtained in between the layer of the in between the junction of two layers. It means that it is confirmed that presence of terpenes in Cassia sophia seed extract. Wanger's test used for identification for the alkaloid compound. Brown color PPT is found at the upper surface. It means that it is confirmed that the presence of alkaloids in Cassia sophia seed extract. Lead acetate test used for identification for the flavonoid compound. The yellow color is obtained at upper surface. It means that it is confirmed that presence of flavonoid in Cassia sophia seed extract. Glycosidase test used for identification of glycoside compound. Yellow color is obtained. It means that it is confirmed that presence of glycoside in Cassia sophia seed extract. Phenol test used for identification for the phenolic compound. The yellow color ring is obtained at upper surface. It means that it is confirmed that presence of phenol in Cassia sophia seed extract. Discussion. Phytochemicals in Cassia sophia aquaethanol seed extract prove the presence of biologically active compounds. Nowadays, plants are considered a better source for new medicines to be discovered than those of microbial and animal origin. The saponin are used for the hyperglycemia, hypercholesteremia, antioxidant, anti-cancer, weight loss, and anti-inflammatory activity. Tannins are astringent and are used for the dysentery and diarrhea. Flavonoids have high anti-cancer properties, while tannin has antibacterial properties. Phytochemicals are also used as dyes, fibers, glues, oil, waxes, flooring agent, drugs, perfumes, and they are viewed as a potential source of new natural drugs, herbicides, antibiotics, and insecticides. Conclusion. Overall, the oral study suggested that Cassia sophia aquaethanol seed extract present various phytochemicals such as alkaloids, free carbohydrates, flavonoid, phenol, tannin, terpenes, saponin and glycosides as a secondary metabolites. Due to the presence of wide range of active phytochemicals, it is possible that the active components that were separated from the species could operate as a lead for the creation of new medications that are very effective against the treatment of diseases. Acknowledgement, I thankful to Dr. V.T. Dhurve, Professor and Head of the Department of Zoology, Mahatma Jyotiba Phule Educational Campus, RTM Nagpur Institute Nagpur. I also thankful to Department of Botany, RTM Nagpur Institute Nagpur for the identification of the plant, and I thankful to my guide Dr. Yassim Masram for giving valuable guidance and support. These are the references. Thank you.
What was the purpose of your study?
I want to research on what is the phytochemicals. So many phytochemicals are present in plants. They are the very important phytochemicals and utilize and used on the very different type of disease. That is the I want to search on the I want to study on that ki how many phytochemicals are available in so many plants. So this is my study is that ki I want to detect the how many phytochemicals and what is the purpose, what is the significance of that phytochemicals in human being and disease. No, ma'am. There are the so many tests, phytochemical quantitative test, qualitative test.
What madam is saying, tannin will be present in all the plants. But you cannot use all the plant as a tannin from all the plant as a medicine.
Yes, sir.
Yeah. So that's what madam wants to say. Yes. Yes.
Yes, ma'am. There are the quantification study and.
Since how long you are working on this topic?
Sir, my work on anti-diabetic. I have to use this plant on anti-diabetic properties.
So you should tell that rather than giving a vague answer like I will search for the chemicals and then search for the disease. So better your answer should have been I am working on diabetes.
Yes.
Right. So I am searching for anti-diabetic drug.
Yes, sir. Have you followed some protocols? Yes, yes, ma'am. Have you followed some protocols to prove it as an
Yes, ma'am. Yes, my work on anti-diabetic activity.
Talk about anti-diabetic. Have you proved it already? Have you started some
Yes, ma'am. Yes, yes, ma'am.
So you could have shown that.
सर वो ऑथर है सर.
There are many grammatical and typographical errors. You must take care when you are presenting.
Thank you. Next research scholar, Pragati Jipkate. His topic is nano biotechnology application in agriculture. Yes. Yes. No, she is absent. Okay. Next is Dr. Kavita Apkazi. Impact electromagnetic radiation in human health care. Is absent. Okay. Thank you. Thank you very much for giving us the opportunity. Thank you, madam.
We would like to express our gratitude to Dr. Zugade sir and respected Dhonde sir. So I request Umre sir to please felicitate chairpersons by offering memento and certificate. Now I request all the participants available in the audience, please come on the stage. We will have group photo, and after that I invite you to join for the lunch. And after lunch, please immediately again reassemble in the hall, because after that in the next session we have thesis presentation. So first please come on the dais for photo, group photo. Sorry. Good afternoon, one and all. Hope you have enjoyed delicious food. Welcome back for the post-lunch session. In this session, we have PhD thesis presentation, and chairpersons for this session are Dr. Prashant Puranik, Professor, Department of Pharmaceutical Science, RTMNU Nagpur, and Dr. M.R. Lanjewar, Department of Chemistry, RTMNU Nagpur. I request respected Puranik sir and respected Lanjewar sir, Lanjewar ma'am, to take seats on the dais, please. So, if comfortable, then you can sit here. What you feel? Sit this way. Sir is with them. See, sir, you are accompanying him. सांगते सर. I request Gajviya sir to welcome Puranik sir and Lanjeva ma'am by presenting sapling. For thesis presentation, three things all presenters should take care of. First one is you have given 13 minutes for presentation and 2 minutes for question answer. So please stick up to the timings, please. And secondly, your presentation should comprise of only 15 slides. Take care of it. And now I request respected chairpersons to conduct the session, please. Ma'am, these are the judges. We have given them already. These are the judges. Yeah.
Good afternoon to one and all the present here. Respected members. Now this session number 11, that is PhD presentation session. Judges for this session is Veena Belgamwar madam, Dr. Veena Belgamwar madam, Dr. Sanjay Dhobre, Dr. Nitin Dongarwar sir, and Dr. Arti Shanware madam. Total 7 presentations are there. Okay, the first session rules already madam has told to you. Okay, so first is the Anup Dhoble sir.
Good afternoon all. I am Anup Dobre, PhD research scholar from Pune University, and this is the topic for my today's presentation. Biodiversity of reptiles and tracking biotic and environmental changes during the late Cretaceous, early Paleocene, Deccan volcanism erosion in India. This highlighted portion is a Deccan trap. This Deccan trap mainly exposed in the central and western part of India. These flows are erupted during the different magnetic crown during the 68 to 62 million years ago. These Deccan flows are classified into northern part of the Narmada Valley is a Mandla group. The eastern part of the Deccan trap is classified as a Mandla group. Then Western Ghats, Saurashtra group, and Satpura group. The Deccan volcanic associated sediments is classified as the infratrapian sediments before the arrival of the flows. They are then second is the intertrapian sediments. The intertrapian sediments are deposited during the pause in a volcanic activity. The Deccan volcanic associated sediments are very ideal for tracking the biotic changes during the Deccan volcanism before initiation of the Deccan volcanism. These are the main riparian biodiversity are recorded from the inland lamina basins and intertrapian associated with the Deccan traps. These are some dinosaur species like Titanosaurus, Sauropod, dinosaurs like Isosaurus, Ginosaurus, then abyssal theropod dinosaurs like Rajasaurus, Gujarat, Rhylosaurus, Rajasaurus, and other dinosaur species are reported from the inland lamina basins. From the inland lamina basins of Balasinor Basin, Jabalpur Basin, and Nandongora Basin of Chandrapur District, Maharashtra. These are some crocodile moths, alligatorine, notosuchid, asinco moth. These and then snakes like Mesoides snakes like Sanaja indicatus, Mesoides pisdorensis. Then some turtle species like Cormordamis also reported from the infratrapian sediments of lamina basins. Some lizards are also reported from the intertrapian sediments. They are reported from the intertrapian sediment lizards. They are reported from the intertrapian sediments after the arrival of the flows. These are the types of fossils generally we study in geology to characterize the taxonomic identification of the fossils. These are the 6 main inland lamina basins. Most of the reptilian diversities are reported from these 6 inland lamina basins, like Sagar Basin, Jabalpur, Amarkantak, Balasino, Salbardi, and Nandongorga basins. These basins are deposited before the initiation of the Deccan volcanism, and they are deposited during the ground zero conditions. They are deposited during the fluvial riverine condition during the semi-arid to arid conditions. And they are the Sagar Basin, Balasinor and Salbardi Basin, and Nandongorga Basin is very well known for the reptilian diversity during the lamina time. We have lots of reptilian biodiversity from the lamina and intertrapian. First is the dinosaurs. Different workers recorded some sauropod dinosaur species from the inland lamina basins of Balasinor Khera basins. The first figure of the Ginosaurus, Titanosaurus, they are reported from the Jabalpur lamina basins, and thus below portion of the left humerus and left femur is also reported from the femur of the Ginosaurus. From these are same, all these species are from the Jabalpur lamina basins of the Madhya Pradesh. These are some theropod dinosaurs are reported from the Balasinor lamina basins like Rajasaurus, Rhylosaurus. These are the skull element, tail vertebra, trunk vertebra, neck vertebra, skull root bend case. There are some dental element. There are all theropod elements are reported from the Balasinor lamina basins of Gujarat. Most of the theropods are reported from the Balasinor basins of Gujarat, Jabalpur basins of Madhya Pradesh, and Nandongora basins of Maharashtra. These are some sauropod theropod dinosaur nest sites. This site indicates that there were well diversity during the lamina time of sauropod as well as the abyssal theropods. The characteristics of these dinosaur eggshells is on their sphericity. The above photographs is the sauropod dinosaurs, and adjacent photograph is the theropod dinosaurs. These photographs are from the Balasura Lametta basins and Sarbadi inland Lametta basins of Madhya Pradesh. These are some coprolites. This is the very unique locality in the world. There is the very unique locality, and it's almost 150 kilometers from Nagpur. There is one locality, Pisdura, in Chandrapur district. It indicates the habitat and diet about the dinosaurs. These are the 4 types of coprolite dinosaurs, classified on the basis of their sphericity and size of the coprolites. My guide, Dr. Samal ma'am, has conducted a palynological study of the coprolites for palynological to study the biota or faunal assemblage during the Lametta time. This plant tissue also suggests some biota or faunal diversity during the Lametta time. These are some snake. These are also reported from the Balasura Lametta basin of Gujarat. This is the Sanaja indicus, and this is the Mesoidipis durensis. These 2 snakes are already reported from the inland Lametta basins. There is no snakes from the intertapian till date. These are some turtles and crocodilomorphs. This is the new turtle we collected from the Dongargaon Basins district in Chandrapur. He is going to publish in few days. And there's already 2 species were published from Lametta basins, like Kurmademis and Shobamis. And there are 2 crocodilomorphs like Notosukit and Samosukit. They are also published or published by other workers from the inland Lametta basins. I'm showing this much diversity of titans, sauropod, theropods, turtles, then crocodile. Because the reptilian diversity indicate there was a good diversity during the Lametta time before the arrival of the Deccan volcanism or before the decision of the Deccan volcanism. This is my actual work I'm going to publish now. These are some lizards. These are the dental element like teeth, maxilla, premaxilla, some dentaries is there, some lizard vertebrate, lizard scale like osteroms. There are some frog element like ilia, frog vertebra, and some frog dentaries. These are not yet published. It's going to publish. We try to study the biotic changes during the initiation of the flows after arrival of the flows. These are collected from the intertapian sediments of Malwa group from my study area. In geological period, there are major 5 extinction. Out of the 5 extinction, Katie boundary is the 5th major extinction. That time, 70% of the biota got extinct during Katie boundary time. Like marine fossils, like ammonites and belemnites also got extinct during the Cretaceous Paleogene time. Earlier, it was considered to be 65.5, but some workers is revised as a 66.05 nowadays, Sperinatol. Big animals like sauropod dinosaur and theropod dinosaur also got extinct during this time. The asteroid impact is initially assumed to be caused by the Katie boundary, but India we don't have any signature for the asteroid impact. In India, we have Deccan volcanism, possible cause for the Cretaceous Paleogene boundary. These are some frogs and lizards. They all are reported from the intertapian sediments. There is no record of any frogs and lizards from the infratapian sediments. They are reported from the intertapian sediments after arrival of the flows during the pause in the volcanic activity. This is the schematic oral biotic scenario in the Lametta time during the Cretaceous Paleogene time. Here I have tried to show the measure of the frogs and lizard reported from this reverse cone. This is the reverse cone. My PhD area is strictly confined to 30 normal. And we are going to report the 30 normal lizards and frogs from the Malwa Plateau. Earlier, the frogs and lizards only reported from the reverse cone from the other intertapian locality like Kisalpuri. In Malwa Plateau, in my study area, I'm going to report the 30 normal dinosaurs from the intertapian. There were no report of any 30 normal dinosaurs from all over the India. We have dinosaur reports from the 29R from the Ranipur intertapian of Madhya Pradesh. We are going to report the 30 number dinosaurs from the Malwa Plateau. These are my significant conclusions. The intertapian and numerous dinosaur bones, nests and eggs different from the megaliths amelisurate theropod during the late Laminar sediments in the rim accretion in 330 normal and 29R. The dinosaurs were affected during the initiation of the Deccan volcanism. There are a couple of species of the titanosauric dinosaur were survived after the initiation of the Deccan volcanism. The last dinosaur got extinct before the KT boundary, almost 350 million years ago, before the 350 years ago, before the KT boundary. The snakes, turtle, and crocodile mob also survived after the Deccan volcanism, but diversity were decreased during the volcanism. And the diversity of the frogs and lizards is increased during the intertapian, and after the initiation of the Deccan volcanism, they maybe enjoyed the warm and humid climatic condition during the volcanism. And in India, there is no any significant clue for the asteroid impact for the KT boundary. Our Cretaceous Paleogene boundary, we correlated our Indian boundary with the Deccan volcanism in India. Thanks. I would like to thank the organizing committee of the symposium. I will also express my thanks to my funding agency and National Ministry of Earth Science. I am also thanks to the Department of Geology, Savitribai Phule University, Pune, and also thankful to Department of Geology, RTM Nagpur University.